Hey, can you lift a truck with your hands? No? Shocker. But let me introduce you to nature's original strongman, the ocean, which casually tossed 700-ton boulders around like they were pebbles during a mega tsunami that hit Africa thousands of years ago. This wasn't just a bad day at the beach. This mega tsunami was so powerful, it made the 2004 Indonesian and 2011 Japanese tsunamis look like kiddie pool splashes. Now, to give you an idea of how terrifying regular tsunamis already are, the Japan tsunami produced waves 133 feet tall. The Indian Ocean tsunami was slightly smaller, but it took over 200,000 lives across many countries. Now imagine something way worse. You see, for a long time, scientists thought waves that big were just science fiction. But then they found these enormous boulders, massive chunks of rock, flung far inland, and did the math. It turns out only waves around 800 feet tall could have pulled off that kind of rocky vandalism. And the culprit? A volcano that literally fell apart into the ocean and triggered one of the most powerful tsunamis Earth has ever seen. Usually, tsunamis are blamed on underwater earthquakes, tectonic plates getting into slap fights. But volcanoes? Oh, they've got tsunami potential too. In 1883, for example, a volcano in Indonesia named Krakatoa erupted for 6 months non-stop until it exploded, and the explosion was heard all the way in Australia. This triggered many tsunamis, some almost 100 feet tall. Still, that was more like a toe dip compared to the full cannonball from the mega tsunami. Back in ancient times, the volcano that crumbled during the mega tsunami was huge, and it didn't just fall apart. It lost a chunk that was 10 times the size of Mount Everest. 10 Mount Everests. It was like the Earth wanted to see what would happen if we threw a mountain into the ocean just for fun. It was so massive that when the entire side of the volcano belly flopped into the Atlantic, it created waves that could cover the Statue of Liberty 3 times. It also destroyed an island more than 30 miles away. The volcano behind this real-life Michael Bay scene was called Fogo, located on, you guessed it, Fogo Island. This island is basically just a whole single volcano that rose from the sea thanks to a magma hotspot, a place in the ocean where a lot of magma escapes and erupts like an underwater volcano. Over time, this magma cooled and stacked up like pancakes until, voila, after 7 major eruptions, the island popped out of the ocean like it was playing peekaboo. Surprise, it's a volcano. But Fogo's dramatic entrance was also a ticking time bomb. You see, the more a volcano grows, the heavier it gets, and if there's not enough magma inside it to support it, the whole thing can just collapse. Sometimes it doesn't take much. A minor earthquake, some erosion, or just a poor foundation made of soft sediment can trigger a collapse. It's like a really tall guy trying to balance over a bunch of marbles. Fogo had all the bad luck ingredients: too tall, too heavy, and built on squishy ground. And it gets worse. As the volcano grows heavier, it starts squishing the magma underneath. That lava can't rise, so it just simmers down there, slowly thickening like soup left on a burner for too long. Gases build up, pressure increases, and eventually, kaboom! It's the volcanic version of eating too many burritos and then trying to hold in a sneeze. This massive pressure and imbalance can trigger what's called a flank collapse, which is science speak for oops, half the volcano just fell into the ocean. That's what happened with Fogo. Most of the volcanic islands that form this way are long gone, but Fogo is still very much alive and kicking. In fact, it last erupted in 2014, and considering that it goes off every 20 years, maybe don't travel to Fogo Island in around 2034. For the longest time, scientists believe only big, bulky volcanic islands could collapse like this. But new research says that even smaller, skinnier guys, like the Danny DeVitos of the island world, aren't safe either. The thing is that small volcanic islands only seem stable because of their small mass. It's like Danny DeVito and Arnold Schwarzenegger both slipping on the ice. Arnie's fall might cause more chaos, but Danny can still go flying. And those little collapses? Yes, they matter. Take Santa Maria, a tiny island that's about 170 times smaller than Hawaii. It has collapsed multiple times, not because it wanted to, but because it's basically standing on soggy breadcrumbs. Its foundation is loose marine sediment, and to make things worse, it's sitting right next to the East Azores Fault, where 3 tectonic plates meet up for daily slap fights. This fault is responsible for many earthquakes and even some tsunamis that happened in Lisbon in the past, so you can imagine what it's like living right above it. Every time the volcano in Santa Maria erupts and grows, it also sinks. But when a chunk collapses, it bounces back up like a buoy. This seamount to island again roller coaster means that Santa Maria has popped in and out of the ocean like a submarine playing peekaboo, and with every peak comes a potential tsunami. Another volcano with similar trust issues is Pacaya, located in Guatemala. Between 2011 and 2013, scientists spotted strange movements in the soil, tiny shifts that suggested something underneath was getting restless. Sure enough, in 2014, Pacaya erupted. Luckily, it didn't collapse, but that risk still looms, especially if magma gets trapped in it like it did with Fogo. The consequences could be explosive, literally. In fact, about 1,000 years ago, Pacaya experienced a collapse that sent debris avalanches more than 15 miles away. Since then, it's rebuilt itself like a fiery phoenix, but it could still crumble again. That's why volcanologists obsess over the tiniest wobbles. It's not paranoia if the mountain really might fall. Now you might be thinking here, okay, but that was the past. Surely that kind of ridiculous mega tsunami collapse can't happen again, right? Well, welcome to the 21st century. Islands like Hawaii, La Palma in Spain, and various parts of the Caribbean are sitting on the same kind of geological whoopee cushions. All it takes is the right combo: loose foundation, steep slopes, maybe some trapped magma, and boom, flank collapse. In fact, it's already happened recently. In 2018, Anak Krakatau, the volcanic baby of the infamous Krakatoa, lost a big chunk of itself during an eruption. It caused a tsunami, but it was more awkward than devastating, like a volcano losing its pants on stage. Embarrassing, but survivable. But that's just amateur hour compared to history's real showstoppers. Ritter Island's 1888 collapse was so intense that the island literally got shorter. It went from being more than 2,000 feet tall to a mere 460 feet. But the record holder is the legendary Latua Bay megasplash from 1958, where a 7.8 magnitude earthquake triggered a massive landslide that sent a wave taller than the Empire State Building roaring through Alaska at highway speeds. Strangely enough, only 5 people lost their lives here, but on the other hand, the destruction path it left behind can still be seen today, all the way from space. Melting glaciers and ice caps can make volcanoes collapse too. When they melt, there's a sudden decrease in pressure on Earth's crust that can destabilize entire volcanoes. It's called isostatic rebound. It's like suddenly yanking a chair out from under someone who's been sitting still for centuries. Whoops. Also, here's something you probably never thought you'd worry about on your island getaway. Some volcanic islands grow outward as lava pours into the sea, creating unstable platforms known as lava deltas. These deltas can collapse without warning, taking newly formed land, and sometimes tourists too, right back into the ocean. No pressure though, just thought, maybe you want to stay off steaming new land. So yeah, next time you're lounging on a beachy volcanic island thinking, wow, this place is paradise, just remember, it might also be a ticking geological time bomb with a flair for the dramatic. From ancient mountain-sized cannonballs to surprise lava deltas, volcanoes have a history of keeping things spicy. So, since 2000, the world has been hit with more than 1,700 earthquakes with magnitude greater than 5. Many happened around the Ring of Fire, located around the Pacific Ocean. In North America, the biggest threat is the San Andreas Fault Line, which can create an earthquake of a magnitude higher than any other, earning it the spine-tingling nickname, the Big One. The potential destruction of California is a terrifying prospect that could have unimaginable consequences. But the Big One is just the beginning of what's to come. Bad news! Scientists have predicted an Earth-shattering event that will occur in 2030. Like it or not, there's a 70% chance that we'll experience the big one, and it will be an earthquake with a magnitude of 6.7. The San Andreas fault line will cause the big one, but what is scary is that we can't predict it. On the other hand, a massive earthquake occurs every 100 years. This means there's always time to prepare for a natural disaster. If we traveled back in time, we'd see a few significant earthquakes like the ones that wiped out San Francisco and Fort Tajon. Buildings made a long time ago are not quake-proof. They will collapse. Even if they survive, you should not enter them. But buildings are not the most dangerous part. You should watch out for electrical lines and gas pipes. Your hill house might be lovely, but it is extremely unsafe. During quakes, the hill can turn into a massive landslide that will destroy everything in its path. Say goodbye to road trips because all the roads will be ruined. You should have some spare water and food since you won't be able to go to the supermarket. This disaster won't be cheap. It will cost the U.S. around $200 billion to recover from the quake. At least the earthquake will not trigger tsunamis. But there's something that can cause more damage than the big one. The notorious Cascadia subduction zones start in California and ends up all the way in Vancouver, Canada. The San Andreas fault line is nothing compared to this zone. It can wipe the whole coast off the face of the Earth, an example of hyperbole. Subduction zones are tectonic plates forced to be one under the other and constantly pulling apart. One is called the North American Plate and the other is the Juan de Fuca Plate. Zones like these are not to be messed with, since they are terrifying hotspots for earthquake activity and extremely dangerous because they cause massive underwater quakes. But they are underwater, so what can they do to us? Well, they can cause giant tsunamis, flooding cities, and destroying the coastline. Right now, the most active zone is the Ring of Fire. The Cascadia zone might be less active, but it is like a sleeping beast that can wake up and destroy everything in its path, causing a groundbreaking earthquake. The last time all this stress was released was in the year 1700. Unlike the San Andreas quake, this one will cause massive tsunamis and much bigger shocks. Let's hope you'll be camping in an open field at that time, because most buildings and bridges will likely be destroyed. Also, be ready for the aftershocks, as they'll be devastating. Nature won't be spared either. Landslides will change animals' habitats. Even our homes will be changed forever. Luckily, there is a light at the end of the tunnel, and scientists are doing everything they can to ensure our safety. New rules are implemented. Every new building must be able to withstand massive shocks. They're developing modern warning systems, and every new infrastructure must follow strict quake-proof guidelines. The Juan de Fuca and the North American plates are locked together, but they won't stay like that forever. When they unlock, get ready for a massive shake. The closer you are to the epicenter, the more damage you'll experience. But even if you are lucky to be far away, you may still feel the ground shaking for some time. Now, if we compare the Cascadia subduction zone and the San Andreas fault, we'll see how much more dangerous the Cascadia zone is. In 1994, there was an enormous 6.7 magnitude earthquake in the Northridge area, close to the San Andreas fault. Sadly, many people didn't make it, and some were injured. Back then, buildings were not strong and earthquake-proof, and many of them were damaged. The Cascadia subduction zone can potentially cause a magnitude 9 earthquake. A magnitude 6 quake has the power of around 44 million pounds of dynamite, but a magnitude 9 has the power of 44 trillion pounds of dynamite. The strongest ever recorded quake was in Chile. Its magnitude measured 9.5, and it destroyed most everything. So let's say you've survived the quake, but the struggle is far from over. Soon after, a massive tsunami will strike, with waves that might reach up to 100 feet in some areas. That's so unlike the San Andreas earthquake, which can't produce any significant waves. So say goodbye to your beautiful garden, since salt water will destroy trees and plants, changing the environment for a period of time. The only positive thing will be you won't need Halloween decorations, because all those dried out trees will resemble a ghost forest. The combination of waves, quakes, and the sheer size of the area will make this natural disaster much more dangerous than any caused by the San Andreas Fault or the so-called Big One. A quake similar to this happened around 300 years ago. Many more have been recorded in the past 3,500 years, proving that they continually occur every 400 to 600 years. So, technically, we have around 100 to 300 years before the next big one hits. We still have no idea how exactly the Cascadia subduction zone works, because we discovered it in 1970. This zone is super scary because it can cause big earthquakes. It was found by accident when researchers studied the Ring of Fire. They wanted to know if this area had caused any trouble in the past years, and the proof was under their noses. In Washington, there is a horror forest where nothing has been growing for years. When researchers tested the soil, they found a tremendous amount of salt. They put two and two together and concluded that a massive tsunami had been the reason. Experts still didn't know when the forest was destroyed. But Japan kept records of a gigantic earthquake that had a similar effect. It was the one that happened in the year 1700. There is a 1 in 3 chance that the next one will occur in 2050. You must know how to survive the Canadian earthquakes and make it out unscathed, so listen carefully. Those who live in this area have almost no experience with earthquakes like this one. Surviving the quake is relatively easy, but the tsunami coming afterwards is the real danger. After the shake, find the highest ground and go there. Only bring the essentials, like food and water. Yeah, leave your baseball card collection at home. After the first hit, don't try to go down. Seismologists say that most likely there will be a few more waves, and they have proven this. On the 22nd of May 1960, seismologist Jerry Eston and his 4 friends went to Hawaii to see an expected tsunami that was to happen around midnight. They set up their gear on Wailuku Bridge with an escape route planned. This bridge had been destroyed in the previous tsunami, but the new one was much taller and better. After midnight, the water was 4 feet above the average level. The second wave hit a half hour after midnight, and the water rose another 9 feet by 1 a.m. The water started going down and dropped by 7 feet, but the horror was far from over. Next, they saw a wave that was around 20 feet tall. This shows us that tsunamis are unpredictable, and we should listen to experts to stay safe.
On January 26, 1700, one of the biggest earthquakes in history hit off the coast of the United States. It had a magnitude of 9, which puts it in the top 10 most powerful earthquakes ever recorded. This earthquake triggered a huge tsunami and changed the coastline all the way from southern British Columbia down to northern California forever. Back then, the area wasn't very populated, but thanks to some clever research, scientists figured out exactly what happened that day by looking at old geological records, tree rings, and even some history from Japan. On the same day as the earthquake, a massive tsunami also hit Japan's eastern coast. For a long time, no one connected the two, but in the 1980s and 90s, researchers realized the tsunami in Japan had been caused by the earthquake in the Pacific Northwest. They were also able to pinpoint the exact day, January 26, 1700. They even found old trees in coastal Washington that had all perished around the winter of 1700, which matched up perfectly with the timing of the earthquake. The earthquake came from the Cascadia subduction zone, a fault where the Juan de Fuca plate slides under the North American plate. This fault stretches about 700 miles, from northern Vancouver Island in British Columbia to Cape Mendocino in California. The pressure from the moving plates builds up over time, and eventually, another big, devastating earthquake will hit the same region. It's just a matter of time. By looking at the geological records, past tsunami deposits, and signs of land level changes, scientists can figure out how often these huge earthquakes happen. Emergency planners have been preparing for the next big quake, often calling it the Big One. Scientists believe earthquakes in the Cascadia subduction zone happen every 200 to 1,000 years. And since the last major one was over 300 years ago, the Pacific Northwest is definitely due for another. When it happens, the earthquake is expected to be as big as the one from 1700. But this time, it'll affect around 15 million people. The devastation will be severe. Buildings will collapse, roads and runways will crack, and bridges will fall. Communication in and out of the area will be cut off. But the worst part? The earthquake will trigger a massive tsunami that might hit parts of the Washington coast in as little as 10 minutes. It's not a matter of if, but when the Cascadia subduction zone will break. When it happens, it will be the worst disaster the US has ever faced. Worse than the Hurricane Katrina or Superstorm Sandy. It'll impact an enormous area, stretching from southern British Columbia all the way down through Oregon to northern California. That means millions and millions of people will be affected. Fairchild is considered a backup staging area for handling the aftermath of the earthquake, with Grant County International Airport in Moses Lake being the main one. For those who will survive the initial quake and tsunami, the aftermath could be just as disastrous. Aftershocks will follow, and transportation will be a mess. Roads will be damaged or completely blocked, airports will shut down, and most of the main routes, like Interstate 5, will have bridges destroyed. This means food and water supplies will be cut off, and it will be incredibly difficult for help to get in or for people to escape. Gas pipelines will most likely be damaged too, and restoring them could take anywhere from a few days inland to weeks or even months along the coast. Power outages will be widespread within 100 miles of the coast throughout the entire Pacific Northwest. And water could be out for 3 to 7 months. Even telecommunications will be down for 2 to 3 months across the Pacific Northwest, Alaska, and even parts of East Asia. The good news for eastern Washington is that it will mostly avoid the worst of it, thanks to natural barriers between the west and east sides of the state. The tsunami may hit the Columbia River Gorge, but it will lose energy quickly because of a sandbar under the river. The Cascade Mountains will absorb much of the earthquake's impact, so the east side won't feel it as strongly. And since eastern Washington won't get hit as hard, it'll be up to them to handle the aftermath of the quake. That means helping western Washington, taking in refugees from the areas that got destroyed, and delivering supplies to where they're needed. Scientists have looked at other major 8.0 to 9.0 magnitude earthquakes like the ones in Chile in 1960, Alaska in 1964, and Sumatra in 2004, and Japan in 2011. These kinds of quakes can shake the ground for anywhere between 6 to 10 minutes, and that's a long time for the ground to be shaking. Such quakes are super intense because they happen close to Earth's surface, so it's not just a quick shake. It's a long, strong one that can cause a lot of damage. If the Cascadia earthquake and tsunami were to hit tomorrow, over 13,800 people could lose their lives, and about 107,000 people could be injured. The economic toll in Washington, Oregon, and California could top $70 billion. To put that into perspective, we can compare these numbers with some other major earthquakes. In Chile's 1960 earthquake, about 1,650 people lost their lives. The 1964 Alaska quake resulted in around 140 lives lost. The 2004 Sumatra earthquake and tsunami took the lives of an estimated 280,000 people. And the 2011 Japan earthquake and tsunami caused over 20,000 casualties. Authorities know about the dangers of the Cascadia fault, but even with all the planning, no one can say for sure what will be needed when the big quake hits. Right after the earthquake and tsunami, the areas outside the immediate disaster zone won't be able to help much because roads and airports will be destroyed, and resources will be limited. How can we deal with this kind of disaster and its effects? We don't have all the answers yet. Right now, let's focus on the Cascadia subduction zone. It's a huge fault line that stretches about 620 miles from Vancouver Island to Cape Mendocino in California, sitting about 93 miles off the coast. It's like one tectonic plate is slowly sliding under another. When the plates are close to the surface, about 18 miles deep or less, they get stuck because of friction, kind of like pushing two rocks together. Over time, this creates a lot of pressure. When the pressure finally becomes too much, the plates slip, causing a massive earthquake. This is called a megathrust earthquake, and it can be huge. Below the area where the plates are stuck, there's a zone where the plates move really slowly. We're talking about just a few inches every few months. This slow movement helps to release some of the pressure, but it also builds up more pressure on the parts of the fault that are still stuck. This means that over time, it increases the chances of a huge earthquake happening. These massive quakes, called Great Subduction Zone earthquakes, can be stronger than magnitude 8.5. Megathrust earthquakes are the biggest earthquakes that happen. They can go over a magnitude of 9.0, which is insanely powerful. Just to put it in perspective, a magnitude 9.0 earthquake releases 1,000 times more energy than a 7.0 and a million times more energy than a 5.0. These earthquakes happen when a lot of pressure builds up in a part of the fault that's locked, which means the plate can't move past each other. When that pressure gets too high, the fault finally ruptures, releasing all that built-up energy in one massive shake. The Cascadia subduction zone is super long. That's why if it were to rupture all at once, it could produce a large earthquake. Scientists have studied this region and found that about 18 miles below the surface, the fault is completely locked. The plates there aren't sliding past each other. But deeper down, the plates start to slide more smoothly, causing less friction. This is important because it tells us how much stress is building up in that locked zone, and how it could eventually lead to a major earthquake.
An earthquake in Indonesia began in 1829 and lasted a mighty 32 years. It reached its climax in 1861 and hit a magnitude of around 8.5. It was caused by the tectonic plates below the island slowly clashing against each other. Researchers discovered that the quake had been building for some time after analyzing the coral in the area. They found it was being periodically exposed to the open air. That was caused by the gradual earthquake moving the land up and down. Scientists call these decades-long silent earthquakes slow slip events. A single lightning bolt can warm the air to around 54,000 degrees Fahrenheit. The heat makes the air expand quickly, creating a shock wave or boom, which we know to be thunder. There are close to 3 trillion trees on Earth. That translates to roughly around 422 trees for every person. Before humans, the number was nearer to 6 trillion. Almost 70% of the Earth's surface is covered by water, which on average is around 2.5 miles deep. 97% of Earth's volcanoes lie underwater, as well as the mid-ocean ridge, a massive mountain range that is over 40,000 miles long. Humans have mined around 190,000 tons of gold from the planet. Experts predict there is around 20% still left to be mined, but this figure is constantly changing. The world's largest active volcano is in Hawaii. Called Mauna Loa, it's over 2.5 miles above sea level. Given that most of it is underwater, the volcano's summit is a staggering 11 miles from its base. That's the same length as over 160 football fields. The highest ever recorded temperature on Earth was a sweltering 136 degrees Fahrenheit. It was recorded in El Azizia, or modern-day Libya, on September 13th, 1922. The lowest temperature was a chilling minus 129 degrees Fahrenheit, recorded at Russia's Vostok station in 1983. Earth is the 5th largest planet in the solar system, behind Jupiter, Saturn, Uranus, and Neptune. It has a circumference of roughly 25,000 miles, and it would take the average person around 8,300 hours to walk around the face of the Earth. The separation between Earth's land masses would make such a trek almost impossible, though. It takes 365.25 days for the Earth to orbit the Sun. Because our calendar years only have 365 days, we add an extra leap day every 4 years to make up for the difference. Russia is the largest country on the planet, with a total area of about 6.5 million square miles. It encompasses more than 1/8 of the Earth's inhabited land area, but still has a relatively small population given its size. Earth is the only planet with one moon. Mercury and Venus have no moons, while every other planet has 2 or more. Earth is over 4 billion years old. Scientists calculate this by looking at the planet's oldest rocks, as well as meteorites that have crash-landed. They used meteorites as they were formed at the same time as Earth, when the solar system was forming. The ground we walk on is basically recycled. The planet's rock cycle turns igneous rocks to sedimentary ones, then transforms those into metamorphic rocks, and back again. Like Earth, our moon also experiences earthquakes. They're less common and intense than the ones we have, and are caused by tidal stresses. A tidal stress is basically the relationship between the gravitational pull of the moon on the Earth and that of the Earth on the moon. Despite being the 5th largest continent, Antarctica holds 70% of the planet's fresh water and about 90% of its ice. Bangkok is the most visited city in the world, boasting 23 million visitors in 2019 alone. Paris, London, Dubai, and Singapore make up the other cities in the top 5. The lowest layer of Earth's atmosphere is called the troposphere and is the reason we have weather. Sunlight heats the planet's surface, which causes warm air to rise up to the troposphere. This air then expands and cools as the air pressure decreases and sinks down, where it is then warmed by the Earth again. Coral reefs are the largest living structures on the planet, with some even being visible from space. Coral reefs hold the most species per area of any of Earth's ecosystems, even more than rainforests. Earth got its name around 1,000 years ago, and it comes from the German word meaning the ground, but there's no evidence to show who actually named it. Of all the planets, Earth is also the only one which is not named after a Greek or Roman deity. The deepest point of the ocean is the Mariana Trench. It's a whopping 7 miles below sea level. Coastlines cover about 20% of U.S. land, but are home to more than 50% of the U.S. population. The Earth isn't actually a sphere. It's more like a squished ball that bulges at the equator. The bulge is caused by the force of the Earth spinning, which makes the north and south poles slightly flat. The Earth spins on its axis, which is basically an imaginary straight line. Earth has seasons because the axis is tilted, causing the sun's rays to hit different parts of the planet more directly, depending on the time of year. If the sun was as tall as a standard door, the Earth would be around the size of a nickel. The Earth's rate of rotation is gradually decreasing. It's happening so slowly that it would take as much as 140 million years for the length of a day to increase to 25 hours.
Get equipped for any season with brand new Brightside merch. Click the link and grab your print.
The biggest animal on Earth is the Antarctic blue whale. It can reach lengths of 100 feet and weigh up to 400,000 pounds, which is around the same as 33 elephants. The temperature at the center of the Earth is around the same as the surface of the Sun, at almost 10,000 degrees Fahrenheit. Earth is around 10,000 times older than humans. Earth is around 4.5 billion years old, whereas humans have been around for, at most, 450,000 years. There are around 34,000 known species of fish. The actual number is way higher, though, as a whopping 95% of our oceans still haven't been explored. America's Route 66 is longer than the journey to the Earth's core. The distance to the core is roughly 2,000 miles. Route 66 is almost 2,500 miles. The Earth is made up of 3 main components: the crust, the mantle, and the core, which is divided into the outer core and the inner core. Scientists have estimated that there are around 8.7 million species on the planet. Out of this, between 1 to 2 million of these species are animals. but roughly 86% of land species and 91% of fish have yet to be discovered by humans. Ancient astronomers used to think that the Earth was the center of the universe. For 2,000 years, they believed the Earth to be static, while other bodies traveled in orbit around us. In 1543, Copernicus published his sun-centered model of the solar system. Earth is the densest planet in the solar system. The density varies across its different crusts, but the planet's average density is just over 3 ounces per cubic inch. Mount Everest is the highest point on the planet. Its peak is the highest altitude above sea level at around 5.5 miles. Each year, 1 septillion crystals of snow fall on Earth. That's a trillion snowflakes. Snow covers about 31% of Earth's land area each year. Of Earth's water, only around 3% is fresh water. The other 97% is salted. Of that 3%, about 2% is frozen in ice and glaciers. So, less than 1% of the planet's fresh water is actually in lakes, rivers, and underground. The world's largest inland body of water, or lake to us normal people, is the Caspian Sea. It has an area of 140,000 miles squared. The world's deepest lake is Lake Baikal in Russia and is 5,300 feet deep. Earth's atmosphere is roughly 78% nitrogen and 21% oxygen, with small amounts of water vapor, carbon dioxide, and other gases. No other planet is believed to have this much oxygen, which explains why Earth is the only planet where life has been discovered, so far. Apart from the Moon, there are 2 asteroids in co-orbital orbits with Earth, sometimes called Earth's second moon. 3753 Cruithne is an asteroid that looks like it's following the Earth in orbit, but it's actually following its own path around the Sun. 2002 AA29 is another asteroid which makes a horseshoe orbit around the Earth that draws it close to the planet every 95 years.
You have friends over for dinner. You set your drink on the counter and go help your friend set out some desserts. When you get back, you notice the liquid in your cup. It's sloshing around and the ice cubes look like ships on a rough sea. Now you feel it too. On the ceiling, the chandelier is swinging like mad. Then you hear someone scream, "Earthquake!" The house and everything in it is rocking back and forth. You try to run for cover, but the shaking keeps you stuck in place, fighting to keep your balance. The cabinets look possessed, and glasses and dishes fly out and smash on the floor. The bookshelves topple over, and everything hanging on the walls sways and falls off. You duck under the dining room table, trying not to get hurt on all those broken dishes. Yeah, you've been through earthquakes before, but none like this. Checking your phone? Typical, no signal. You can't believe what's about to happen. The screams get louder, and suddenly the whole house collapses. The biggest earthquake ever recorded happened in Chile in 1960. Disaster came in the afternoon, just when everyone was out enjoying themselves. To cause serious life-changing damage, you need to have a magnitude of around 7 or so on the Richter scale. This one was 9.5. This part of Chile is smack dab on the so-called Ring of Fire, the most active volcanic and seismic area in the world along the Pacific Rim. The initial shaking lasted around 10 minutes, and after 2 days, many aftershocks were still strong enough to set off a volcano in the south of the country. But that's not where it ended. The earthquake unleashed a series of tidal waves all over the Pacific Ocean, with some reaching over 80 feet high. The waves and earthquake were so strong that they even affected Hawaii, Japan, and the Philippines. It caused around $500 million $1960 worth of damage. Many were left homeless. Much of their infrastructure was smashed too. Buildings as far as the eye could see were toppled, and debris piled everywhere. Scientists estimate that this earthquake was so powerful, it shifted the Earth's axis, making our days 1.26 microseconds shorter. That might not seem like a lot, but think about it. Just one natural disaster was strong enough to make time move. Many of the coastal cities were flattened and floods were widespread. The economy spiraled downward. According to studies, if this earthquake happened today, it caused more than $20 billion in damages. So, what would happen if an earthquake twice that size hit without warning? For starters, you'd likely feel the effects even further away. Tidal waves wouldn't just hit the coasts of Japan and the Philippines. They would move even further to China, Korea, Vietnam, and even Australia. And those waves would be significantly higher than 80 feet, perhaps double that. That's like 8 giraffes piled on top of each other, surfing your way. If you lived by the coast, you'd notice the waves. If you saw the water recede way back so you could practically see where all the fish call home, you'd know it was time to run. Chances are that a tsunami's heading your way. Say it really happens. You're caught under the wreckage, not knowing what's going on. You manage to free yourself and escape to the fresh air. And you're not alone, because all the houses in the neighborhood have turned into piles of bricks and rubble. The bridges have also collapsed, leaving people stranded on either side. You look around, dust yourself off, and rush to find help. Fire trucks and ambulances drive between the broken-down cars and rubble. You try to make it to your car, but the aftershocks are still hitting, and you're getting tossed to the sidewalk. With all the cell towers down, you can't call anyone on your phone. Your knees are shaking, but you manage to power through. Once you reach your car, you see it crushed under a boulder, like a giant soda can. You continue on foot and eventually reach downtown. It looks as if some giant got angry and knocked all the buildings down. You push forward and try to see if you can find some help. Without warning, your phone vibrates. You check it and see 1,000 notifications about a 20-magnitude earthquake. You're still shaking, but that's all you. The ground is still for now. Uh-oh. You hear something in the distance, racing towards you. To your right, you see tidal waves as tall as buildings charging at you. Still in shock, not knowing what to do, you now come to your senses and run. You don't even know which way to go. There's a tsunami right behind you, and in front of you are broken down buildings with rocks and concrete still falling everywhere. Wait, there's a building that's somehow still standing. You need to get on top of that thing. You reach the elevator, but it's jammed. Not surprising. You bolt up the stairs as fast as you can, tripping on broken glass and plaster, but always managing to get back up. You look out a window and see the water. It's so close. You're nearly at the top. A few more flights and… whoosh. The water forces its way into the building and drags you down at least 2 floors. You can barely see anything. Still, you know you must swim up. But the water keeps forcing you downwards. After about 30 seconds, you manage to swim your way out and continue climbing to the top. You scramble to the top floor and collapse on the roof. You're safe for now. The tidal wave is still going strong, plowing its way through the ravaged city center. Your phone is now waterlogged and useless. You have a perfect 360-degree view of your town covered in water and debris. The ground starts to shake again. Maybe you'll just sit around until this is all over, waiting for the rescue helicopter. But then, a loud explosion that almost breaks your eardrums shakes the ground even more. Off in the distance, smoke is rising, and soon it covers the entire sky. Darkness hides the morning sun. That's when you can see lava shooting up into the air and landing nearby. The lava forms into a river, flowing its way into town block by block. With this much seismic movement and the high intensity of the earthquake, the world's tectonic plates have shifted so that magma is pushing its way to the surface. From the earth, steam begins to vent. Then the heat hits you. You see the magma cover the ground like a blanket, eating up every car in its way. What's worse is that the magma is melting the foundations of the buildings that managed to withstand the earthquake and the tsunami. The buildings in the distance are now sinking and collapsing into the raging lava pool that's replaced your town. One by one, every building descends. That means, uh-oh, the building where you're standing is also swaying. It's about to fail. That's when you see the light. You look up and see a helicopter above in the distance. You wave your arms, run around, jump, anything to get noticed. And it works. The chopper makes a few circles and finally drops you a rope ladder. As you're lifted in the chopper, You take a good look at the world below you as it wriggles around like noodles in a strainer. You land a few miles out and are immediately treated by a doctor in an emergency triage center. You were one of the lucky ones. A year later, the tsunami water has receded. The lava that flowed inland has cooled, but all that magma permanently changed the ground below it, and the whole town is gone. The disaster has thrown the entire country into a financial nightmare that'll last decades. It takes months to survey the town, making sure there's no dangerous electrical wires or busted gas pipes anywhere. They're rebuilding your town farther inland from where the old one was. In other towns, they rebuild directly over the ruins. In others, they just decide to move everyone to a nearby city. In November 2020, a wave the height of a 4-story building was recorded off the coast of Vancouver Island, Canada. The team at Marine Labs, the company that operates the buoy that got caught in it, couldn't believe the data they saw. Everything was normal, then, unexpectedly, a vast force came, pulled the buoy down, and then sent it up to a peak before taking it even deeper. The probability for such a huge wave to form is once in 1,300 years, so they had to be sure it wasn't a technical mistake. Marine Labs sent the data to a rogue wave scientist at the University of Vancouver. They analyzed and validated the findings and shared them in February 2022. The wave officially became the most extreme rogue wave ever officially recorded, as it was 3 times the height of waves around it. Luckily, this giant didn't leave any damage, as it happened too far offshore. For centuries, rogue waves were believed to be real only in the stories of sailors. Christopher Columbus himself mentioned a rogue wave, but back then, it wasn't officially a thing. In August 1498, he was on his 3rd expedition to the Americas. As they were passing through a strait near Trinidad, a huge wave lifted the boats. They managed to survive and continue the journey, and the area is still known as the Mouths of the Dragon, named this way by Columbus. Back in 1826, a French scientist and naval officer was crossing the Indian Ocean on his ship, the Astrolabe. They got caught in a terrible storm and witnessed several waves over 80 feet tall. One of them was the height of a 10-story building. The crew lost one of its members, but the 4 of them, including the captain, made it to land and spread the story of the gigantic waves. But back then, scientists were sure waves couldn't be taller than 30 feet. So everyone took this story as a tale. Witnesses shared many other stories of giant waves coming out of nowhere, but scientists officially recognized the first rogue wave only in 1995. It went down in history as the Doppler wave, or the New Year's wave. This sea monster of the North Sea hit the Norwegian gas platform Draupner on New Year's Day. It reached a height of 84 feet. The waves surrounding it were twice as small. The rig was built to withstand waves up to 64 feet tall and had the most advanced sensors for its time. It became a sensation in the scientific world because it wasn't like any other type of wave they'd studied before. So they gave rogue waves an official definition. It's a wave more than twice as tall as others around it. These bad boys, also known as freak waves, monster waves, and episodic waves, can pop up lightning fast in a stormy sea or show up out of nowhere in calm waters. They have steep sides and a deep trough below, and look like a wall of water rising out of the sea. They're so intense that they can even swallow up rescue helicopters just trying to do their job. Rogue waves aren't the same as tsunamis. Tsunamis happen when there's a big shift in water, like an earthquake, volcanic eruption, or landslide. They mess with the entire water column. At sea, you might not even notice a tsunami cruising beneath you, but near the shore, as it hits shallow waters, those waves can shoot up to crazy heights. Rogue waves are formed at the surface level, although sometimes they can form deep below, and these are called rogue internal waves. Scientists and sailors singled out some statistics. Rogue waves more often form when wave trains run into fast ocean currents. The coast of South Africa is one good place for that. There are concerns that these water beasts may happen more often in the future because there's more energy in the atmosphere and ocean. It means larger and more frequent rogue waves and more ships lost at sea. Rogue waves aren't limited to oceans and can even occur in lakes. Lake Superior witnesses something that got the name Three Sisters. It's a series of 3 large waves, one after another. The second wave covers the ship decks before the first one is gone. The third wave jumps in and adds extra water. These 3 sisters overload the ship. There's a theory that this phenomenon took down the steamship Edmund Fitzgerald in 1975. Rogue waves are also dangerous because they form rogue holes in the water. When the wave builds up, it draws in all the water around it. So, near the base, these holes can be very deep. If the bow or stern of a ship ends up in one, the ship can instantly sink. Some oceanographers believe that rogue waves are to blame for the disappearance of ships in the notorious Bermuda Triangle in the Atlantic Ocean. Storms from several directions converge in this mysterious area, so rogue waves are more likely to gain force here. And because they can reach a height of 100 feet, they can theoretically bring down an airplane, not just ships. There are 2 main theories trying to make sense of how rogue waves happen. First up, we've got the linear addition theory. Imagine waves cruising through the ocean at their own speeds. Now, when these waves cross paths, they team up and become stronger, cooking up a rogue wave. Then there's the nonlinear focusing theory. It says waves like to roll in groups, and when they spend time together, they share some energy. Sometimes, this energy exchange turns into a rogue wave. To predict the formation of these freaky waves, scientists would need an innovative radar system to keep a constant eye on the waves near a boat. They'd collect all the data and toss it into a fancy math model that paints a real-time picture of what the ocean surface looks like at that very moment. This model would need to do new calculations of the surface situation every 5 minutes. It would let the crew know if there were any extreme waves coming up in the next several minutes. Such a system doesn't exist yet, but as scientists measure more rogue waves, mathematicians may find a way to alert us of the upcoming rogue waves rising out of the water. Sometimes you can hear the term sneaker wave as a synonym for rogue waves, but oceanographers claim there's a difference. Rogue waves occur mostly in the ocean, and sneaker waves build up at the shore. They're also known as king waves and sleeper waves, and they roll up much faster than usual waves when they approach the beach. They always appear without warning after smaller waves and can be powerful. They can carry swimmers further away into the ocean. But the worst part is, they can also sweep you off your feet and into the water when you're casually strolling on a jetty or the beach, or on an outcropping nearby. Oregon State University researchers found that sneaker waves form in offshore storms that carry wind energy to the ocean surface. With all that energy, several waves unite and overlap into one beast that stands higher and goes further ashore than a regular wave. Another thing that makes them more dangerous is that, just like rogue waves, they're hard to predict. Fishers, surfers, and others who spend a lot of time by the water normally know when and what to escape when it comes to big waves. With sneaker waves, that logic doesn't work. There is no set time of the year when they're more active either, but putting together some data shows you're more likely to experience one of those somewhere between April and October, and the peak would be in October and November. Sneaker waves carry huge amounts of water, sand, and gravel. Those can fill up your shoes in a matter of seconds and sweep you off your feet if you're unlucky enough to be ashore at that moment. These sea monsters also have the power to move huge logs, which carries another hazard.
A magnitude 15 earthquake has the potential to completely destroy our planet and evaporate all the water in a matter of seconds, leaving Earth uninhabitable. Over 500,000 earthquakes happen annually, but none have a magnitude of 15. 90% of quakes occur in the terrifying Ring of Fire zone located around the Pacific Ocean. The ground there is like jello. It shakes almost constantly. The most powerful earthquake to have ever struck Earth had a magnitude of 9.5. That much power can lengthen or shorten the day. But there's probably an earthquake in the confines of your own home now caused by a speck of dust landing on a table. But it has a power of negative 15 magnitudes. Earthquakes happen when tectonic plates move. They're like Lego pieces that are not properly secured, and when they move up, down or hit one another, the ground also moves, triggering earthquakes. This tectonic energy acts like a battery. It stores energy for a long time, up to 500 years. When this stored energy is released in a sudden burst, the consequences are horrifying. Even the strongest structures submit to this relentless force that leaves a trail of destruction in its path. In some instances, earthquakes can even trigger tsunamis, amplifying the chaos. Such a crazy amount of power can split the ground open and cause severe damage. The strength of an earthquake is measured by the Richter scale, but now it's being replaced by the moment magnitude scale. When there's an earthquake, we hear about how strong it is. It's usually from 1 to 10. Luckily, we haven't had a Richter scale earthquake yet. The most powerful earthquake to have ever happened in modern history occurred in Chile in the 60s. It was around 9.5 on the Richter scale, and it altered Earth's rotation and messed up the length of the day by around 2 milliseconds. It also triggered a massive tsunami and affected a vast area of 155,000 square miles. The Richter scale doesn't actually have a limit. Still, anything above 25 doesn't need measuring, because if that ever happened, we would simply turn into dust, and nobody would care to measure this disaster. As we said, the strongest earthquake had a magnitude of 9.5. If this magnitude had been just 0.5 stronger, it would have created a ruptured line 2,174 miles long. That is almost 7 times the size of Wyoming. A magnitude 11 earthquake would create a crack halfway around the world. Massive tsunamis would hit coastal areas, destroying everything, and Earth would get into a massive environmental crisis. If you love hiking, you would have new mountains to explore, created by the terrifying earthquake. Even the temperature would increase because of volcanic eruptions and the resulting greenhouse gases. It would turn our planet into a hot oven. The safest places would be far away from any buildings, seas, oceans, and mountains where there would be a low chance of a landslide. Countries unprepared for earthquakes would be totally destroyed, and cities would turn into piles of rubble and dust. Going up on the Richter scale would only make things worse. But don't worry, an earthquake of that power is impossible. Earth's crust doesn't have enough energy to produce such earthquakes. But there is something that has much more power and can produce mega earthquakes. Asteroids are powerful enough to destroy our planet, as we all know from the dinosaur era. That asteroid was around 6 miles long, and it caused massive damage to the planet. It triggered earthquakes that shook the ground constantly for months. These terrifying quakes were about 50,000 times stronger than the Chile earthquake. They also triggered a tsunami that was 30,000 times more powerful than the Indian Ocean tsunami. And the latter was one of the most devastating tsunamis to have ever struck Earth. The earthquakes caused by the asteroid had a magnitude of 11, making it the most powerful and scariest natural disaster ever. And let's hope it stays that way. The Indian Ocean tsunami affected only certain areas of the world. Meanwhile, the asteroid tsunami affected every part of the world and had 33-foot-tall waves. Even if you had traveled to the most remote place on Earth, you wouldn't have been able to hide from this Grim Reaper. A 15-magnitude earthquake wouldn't be 15% stronger than the Chile earthquake. The scale doesn't work like that. It would be around 100 million times more powerful than a 9.5 magnitude quake. It could make all the water on Earth evaporate, leaving us devastated and without any H2O to survive. All ecosystems would collapse, all food chains would be broken, and only some super strong bacteria would probably survive the impossible. That is only a fraction of the frightening things that could happen. The ocean is like the AC for our planet. Without it, Earth would be super hot. The ocean also serves as a shield from the sun's powerful rays. It acts as a heat absorber and cools Earth. Scientists think that the most dangerous thing would be the inability of Earth's crust to survive the violent shakes of the 15-magnitude earthquake. If our planet miraculously survived and didn't turn into dust, there would be massive openings in its crust. The ground would become gelatinous. It would randomly move up, down, left, and right, and no building would survive that. our civilization would be brought back to the Stonehenge era. Tectonic movements like this are devastating. A similar thing happened in Japan when tectonic plates moved 165 feet from each other and then snapped back together, creating a 9-magnitude earthquake. No place on Earth is immune to this bone-chilling natural phenomenon. Still, certain places have higher chances of being destroyed than others, like the Ring of Fire, where 90% of earthquakes happen. This is a place where earthquakes are almost everyday occurrences. The Ring of Fire is located in the Pacific Ocean. It forms a ring around the continents that surround the Pacific. There, several tectonic plates meet, creating highly unstable ground. To make the problem much more terrifying, 75% of active volcanoes are located in this area. 90% of dormant volcanoes are also there, making this place extremely dangerous. Scientists carefully study this region to find a way to predict when the next earthquake might strike. The Ring of Fire is not the only place at risk of earthquakes. In California, along the San Andreas fault line, 2 tectonic plates have been storing power for more than 200 years. The San Andreas Fault is 715 miles long and has the potential for a massive earthquake. This region has its fear of violent earthquakes like the one that happened in San Francisco in 1906. It had a magnitude of 7.8 on the Richter scale. Scientists' predictions are terrifying. They say that the chance of a 6.7 magnitude earthquake is very high in the area. If all hell starts to break loose, you should know how to survive. Avoid anything that might fall on you, like windows, closets, or unstable ceilings. The official phrase from emergency experts is drop, cover, and hold on. Stay low to the ground. Hide under something stable like a table, and remain there until the shaking stops. Make sure to stay in your shelter for another minute or two, just in case there are aftershocks or loose debris. Use your nose and smell for gas. If you do smell it, don't turn the lights on or do anything that might ignite it. Stay strong and be safe. You rub your eyes, trying to make sense of everything. Perfect circular holes in the bottom of the ocean floor off the coast of Big Sur in California. You have no idea how this happened, even though you're a marine biologist who's been practicing it for years. You go through some of the old records and find out that these holes have been around since the 90s. In 1999, a ship-mounted sonar conducted a survey and found 5,200 of these pockmarks, or large holes over 500 square miles, on the ocean floor. They look like moon craters underwater. You contact your team and get the robot ready to go down and explore the scene and bring back a few samples. You and the team drive to the coast and hop on the boat. You're sitting inside controlling the robot with a joystick. Your teammate sets the robot in the water and drives it down. Everything seems normal near the surface, but as the robot goes lower, the pockmarks start appearing. A bunch of boats swift past you, making you lose your balance and focus. The robot turns on the flashlight so you can see better. But as it goes lower, the resolution is less crisp. It almost reaches the bottom, and the holes are smooth and nearly perfect circular shapes. Some of these holes that were visible in the sonar reading measure more than 30 feet across and 15 feet deep. You show the rest of your teammates the images, and they're shocked. The robot continues swimming, but there appear to be more holes all around. Many of them are too small for the scanner to capture from above. These microdepressions are steep and have sort of tails going in a certain direction. It's possible that the currents underwater played a role in their shape. Everywhere the robot swims, there are new holes all around. After a couple of hours, the robot goes back to the boat with some samples. You take them back to the lab and study them. The robot clearly captures images of human trash, but the samples don't indicate anything alarming for now. Despite the fact that 1/3 of the pockets are filled with trash, there's still no explanation of how they were formed. It's late at night and the rest of your team heads back home. You're passing out in the lab, still trying to find some answers. You wake up the next day, and while cooking breakfast, you get this idea that maybe these holes are gases venting out, which could be harmful to marine life. You quickly get the robot and sail out to the ocean once more. This time, you didn't even think about calling your teammates. You place the robot in the water and get behind the screen to control it. The robot descends to the bottom of the ocean and does a survey. So far, the holes still seem to be covered with trash. But some of the holes have marine life dwelling inside, like fish and seaweed. After much scanning, it doesn't look like they're producing any bubbles, which means there aren't any gases venting out, but you're determined to find them. After a while, you reach one of those large pockmarks, and the robot starts scanning around. You find some bubbles coming from a source, but the robot can't reach it. It swims around trying to find a spot, but nothing. You bring the robot back to the lab and work on it. You attach some mechanical arms on it that can lift things and move them. You bring the robot back down to the same spot, but the bubbles aren't as frequent as before. You use the arms to move some of the trash and find out that the bubbles are being produced by a group of crabs chilling next to a pile of plastic. Bingo! The bad news is, you still don't have a clue why the microdepressions and pockmarks exist. As you try to control the robot to go back to the surface, an octopus wraps its tentacles around it, pulling the robot down. You struggle with the controls and push it to maximum power, but the suctions of the octopus are too strong to break off. It's a game of tug-of-war with the octopus and your robot. It takes the robot under a pile of trash, thinking it's lunch. But you use the arms to maneuver the robot out and swim back to the surface. You go back to the lab even more confused. The robot has collected more samples for you to study. Your eye is glued to your microscope, trying to figure out what's going on, but nothing. You decide to do a carbon dating test to determine how old these holes are. After a while, you check out the results and are even more stunned than before. They show that the holes are around 400,000 years old, so it's likely that human trash wasn't the cause for all this. You pull many all-nighters trying to figure out the truth. You gather your team once more and hold a small press conference about this. You claim that this may be something we should be extremely worried about, but you still can't tell them more than what you know. With all the brain work put together, you find out that the large pockmarks haven't changed or been active for more than 50,000 years. The newer holes were most likely created by human trash settling in the bottom of the ocean floor. The marine life gathered some of this trash like plastics and discarded fishing gear and created homes for themselves. This is why around 4,500 of the holes are newer and have trash in them. But it still doesn't answer why the holes appeared in the first place. You're back to square one. The only way to see what's really going on is to clear up the trash from underwater and study them. The story makes headlines in the local community and catches the attention of a cleanup crew. You organize a trip to the ocean and begin the extraction of all the trash. Many cleanup boats arrive and everyone drops down a net to collect the trash. You send down the robot once more to make sure the nets are hitting the right spot. As most of the trash is being collected, many marine life animals scramble and try to find a way to escape. Everyone makes sure not to hurt them. After a couple of weeks, all the holes are cleared up from the trash. You do another sonar scan from the surface and can see the holes clearer than before. But you still don't have an answer for this. You do some more research trying to see if any other holes appeared around the world. On the other side of the country is a mysterious blue hole off of Florida's Gulf Coast. You catch the nearest flight to Florida and make an appointment with the scientist in charge of the expedition. Blue holes are underwater sinkholes that open below the seabed. Just like on the surface, the underwater world also has sinkholes. This one is called the Green Banana and is 150 feet below, and the hole is 435 feet deep. You dive with some special gear with the rest of the team to a barren ocean floor, and the hole is right there in front of you, looking like an oasis in the desert. You and the rest of the scientists are surprised by the diverse marine life dwelling within. Some sea turtles swim past you, and even sharks. These ones don't harm humans. Halfway through, you reach a narrow path, which makes it difficult for humans to pass through. But everyone is careful. There are corals, sponges, mollusks around the corner. You collect some samples and go back to the lab. Blue holes in general are richer in nutrients than barren lands and host plenty of unique marine life. They're quite common and don't pose any sort of threat to anyone. After making the connections, you don't think the holes off the coast of California have anything to do with blue holes. The mystery goes on.
Back in 2018, the biggest active underwater eruption ever happened, at least the one that we could officially record. Scientists followed earthquakes that struck the area in the western Indian Ocean off Madagascar. Between 2018 and 2021, over 11,000 earthquakes struck a small island called Mayan between Madagascar and Mozambique. The strongest one had a magnitude of 5.9. Until then, this area had been pretty peaceful. There had only been 2 earthquakes recorded over 50 years. Along with regular earthquakes, there were also some unusual seismic hums, like earthquakes at pretty low frequencies, forming deep underground. People couldn't feel those hums at the surface, but researchers around the world discovered them and realized they were related to volcanic activity no one actually noticed coming. Something strange happened. That underwater eruption created a giant skyscraper-sized volcano. This new underwater volcano turned out to be around 1.5 times the height of One World Trade Center in New York, and almost 10 times bigger than the Statue of Liberty. The area where it appeared had been explored in 2014, but it was almost flat, peaceful, and empty back then. Now, there is an actual volcano nearly 8,500 feet below sea level. The volcano gets its magma from a super profound reservoir located nearly 34 miles underground. It's the deepest reservoir of volcanic magma that we know about. The Earth has layers, and the middle one is kinda chunky. It's very much like peanut caramel filling many chocolates have. Research shows there are probably hunks of oceanic crust deep inside the Earth's liquid mantle. They're stuck there, creating large lumps in something that was supposed to be a smooth layer. Our planet has a rigid outer layer. It includes a hot upper mantle and cracked crust. The hot mantle moves and churns all the time, making the crust at the surface move too. This way, the oceanic crust dives into the depths and makes huge magma plumes go up toward the planet's surface. Scientists even found an ancient piece of the Pacific Ocean hundreds of miles underneath China. Those are the old remains of the Pacific seabed from long ago, and they were pulled downward below Earth's surface into the mantle transition zone. This rocky slab that used to be at the bottom of the ocean is made of the crust and some solid parts of the upper mantle. Most of the volcanic activity on our planet happens where we don't even see it, under the surface of the ocean. About 70% of all volcanic activity happens in the oceans, and mostly in the area of the South Pacific, with over 1,100 volcanoes squeezed into that area. Coastal cliffs, mountain changes, soils, and sediments that line valleys. These are only a small portion of the rocks on our planet. Oceans hide so much more deep down below the Earth's surface. In between the Earth's surface and its core is the mantle. It's a warm, thick layer of rock that moves and flows constantly. Some hundreds of miles below, there's a place where diamonds grow. As they form, they go through high temperatures and pressure, after which they eventually freeze. That way, when they arrive at the surface, scientists can explore their structure, find out how they formed, and understand better what's going on in the depths of our planet. Thanks to diamonds, they realized the mantle was very wet, and it possibly contained much more water than all the oceans on Earth. Our planet is eating up its own oceans. As its tectonic plates move, dive, and go beneath one another, they drag huge amounts of water into the Earth's interior. The water beneath the surface of our planet can help with developing magma and lubricate faults, which actually makes earthquakes more likely to happen. Water is actually stored in the minerals. It gets incorporated into the planet's crust when new oceanic plates form. They go through the process of bending and cracking as they grind under other plates, and huge amounts of water then go deep into the crust and mantle. Scientists research an area that's 18 miles under the surface. They realize these zones pull 3 billion teragrams, which is more than 2 billion pounds. Any ocean is like a whole new world. There are incredible sceneries below the surface, magnificent waterfalls, lakes, and rivers. There are thick layers of salt beneath the seafloor, and rivers and lakes form because seawater goes through those layers and dissolves them, creating something that resembles pools. The dissolved salt makes the surrounding water denser. That water then settles there, which eventually forms underwater lakes or rivers. But there are also mountain chains, trenches, canyons. There's a canyon in the Bering Sea with more than 8,500 feet of vertical relief. This makes the Grand Canyon look way smaller than it is, since the underwater canyon is nearly 2,500 feet deeper. Deep parts of the ocean are really cold. The temperature of the water can be about 40 degrees, but at the bottom, water can get boiling hot. There are hydrothermal vents in the seafloor. Those are the hot springs located at the edges of tectonic plates. The water they release can reach a temperature of up to 750 degrees Fahrenheit, but the pressure at such depths is very intense. So intense, no human being can handle it. Still, it's the pressure that keeps the water from boiling. Ocean depth is on average 2.3 miles. Light waves can still enter at 3,280 feet, even though it's in a very small amount, so all the mysteries hidden below that point remain in total darkness. The actual illuminated part of the ocean goes until 600 feet. Even though the sun gives us light, most of our planet is dark all the time. It's all because of the oceans, covering over 70% of our planet. The loudest sound that came from an ocean, and of the loudest sounds ever recorded, came from an ice quake. It was so loud, researchers picked it up by sensors more than 3,000 miles away. There was a seismic activity that made frozen ground break down. The Antarctic ice sheet is bigger than the continental part of the United States and Mexico together. A big iceberg from Antarctica holds over 20 billion gallons of water, which could make a 5-year water supply for 1 million people. Humans can generally drink sea ice, although we can't drink sea water. As time goes by and the ice ages, the brine trapped between ice crystals drains out. That way, ice becomes fresh enough to consume it. If all the ice sheets and glaciers we have on the Earth melted at the same time, the sea level would rise another 260 feet, which is just a little shorter than the Statue of Liberty, the height of a 26-story building. Clams live long enough to tell us more about oceans past. Ancient mollusks can live for more than 500 years. To learn more about a tree, you can use its rings to see how old it is. To learn how old a mollusk is, you can examine its rings within the shell and tell. This is also how scientists get information about the ocean, climate, and whatsoever. Clams can help take a look at what happened about 1,000 years ago. The Earth doesn't have 4 but 5 oceans now. The new one, called the Southern Ocean, was officially recognized only a few months ago. It borders the Atlantic, Pacific, and Indian Oceans, so scientists couldn't agree if it's really a new ocean or just part of the colder regions of these 3. We don't only divide oceans on maps. Each has different conditions for unique marine species. For example, the Southern Ocean has leopard seals, orcas, minke whales, emperor penguins, and other animals that live in cold, icy seas. It's also home to krill, small creatures that look like shrimp and are food for many bigger animals that live there. Life on our planet started about 3.5 billion years ago. I wasn't around then. It's still a mystery how and when exactly, but some theories say life could have first emerged in the depths of the ocean. A few years ago, scientists found microscopic tubes and filaments within rocks formed about 4 billion years ago. These rocks are fragments of ancient oceanic crust. Also, these tiny tubes and filaments are similar to microbes that can still be found on hydrothermal vents in deep parts of the ocean. The idea is these living cells found conditions to stay alive in tiny rocky pores inside the chimneys of those vents, and started the amazing adventure of the evolution of life on our planet. There is a powerful force hiding underground where tectonic plates meet, and one forces another under it. This happens in the Pacific and Indian Oceans. Strain builds over centuries. The tension is unbearable until the megathrust awakens. The Earth shakes with a magnitude that can exceed 9 points, more powerful than any other earthquake. When the seafloor suddenly gets pushed up fast, it sends a huge ripple across the water, and a tsunami of huge force is out. These waves are called teletsunamis, and they cross entire ocean basins, ready to take over coastlines thousands of miles away. The thrust fault stretches over 600 miles. The Earth is not just shaking, it feels like it's tearing apart. This is the power of a megathrust earthquake. Those caught in its path will have to fight for their lives. Japanese authorities recently had to issue their first ever megaquake advisory. It happened because of a strong tremor on the edge of the Nankai Trough ocean floor zone. In the end, most of the warnings were lifted, and there wasn't much damage from the 7.1 magnitude earthquake. Parts of southwestern Japan started to shake, and the superfast trains in Japan slowed down to stay safe, which made travel slower for everyone. But everyone is staying alert as they know about the risk of a megathrust earthquake that could happen within the next few decades in the Nankai Trough. The tectonic plate under the Philippine Sea is slowly sliding underneath the land where Japan is, moving just a few inches every year. The last big earthquakes from this area happened in 1944 and 1946, both with a magnitude of 8.1. These quakes have caused a lot of destruction in the country. The next megathrust earthquake in the region, if it does happen, could be between a magnitude 8 and 9. Scientists still can't agree on how likely this mega earthquake is to happen, but it could be up to 80% certainty. On the other side of the Pacific, scientists from the U.S. Geological Survey have studied a dangerous area along the U.S. West Coast. It's called the Cascadia Subduction Zone, and it stretches from northern California to northern Vancouver Island in Canada. Over the past 14,200 years, there have likely been at least 30 big earthquakes in this region. One major quake happens every 500 years on average. But for a long time now, Cascadia has been quiet, and it worries scientists. They think this might be because the area is locked, meaning the tectonic plates are stuck together and building up a lot of pressure. Eventually, the part of the seafloor could suddenly break and move by several feet. The shaking would be just 5 minutes, but it would create a powerful tsunami as the seafloor shifts that would last for 10 hours. If it happens, it's going to be the worst natural disaster in the country's history, according to experts. The ground on some inland hills could turn into something like quicksand. This would cause the hillsides to slide and crumble, taking down roads and bridges. Around 620,000 buildings could be badly damaged or even collapse, including about 100 hospitals and 2,000 schools. People in Washington state might have to take care of themselves without help for 2 weeks, finding food, water, and shelter on their own. Scientists are studying slow slip events, where the tectonic plates move very slowly over weeks or months, releasing some energy but not enough to stop a big one. Every time the magnitude of an earthquake goes up by just one number, the energy it releases is 40 times bigger. So we'd need about 1 million small earthquakes every day for 500 years straight to release the same energy as one huge magnitude 9 earthquake. But these small earthquakes might be clues that a bigger earthquake is coming. To better monitor the Cascadia Fault, experts are mapping the fault more accurately and adding better monitoring tools offshore. Scientists receive over $10 million to install seismic sensors and seafloor pressure gauges on a fiber optic cable off the coast of Oregon. The goal is to be ready to warn people and potentially save lives when a big earthquake strikes. A sharp megathrust earthquake happened in this part of the world in 1964. It went down in history as the Great Alaska Earthquake and had a magnitude of 9.2. It lasted for more than 4 minutes, making it the most powerful earthquake in the history of the U.S. and North America. The ground shook so hard that it caused huge cracks and landslides. In Anchorage, many houses, buildings, and roads were destroyed because they weren't built to handle such a big earthquake. In some places, the land was permanently changed. For example, the coastline near Kodiak and Hinchinbrook Island was lifted by 30 feet. In other areas, like Gurwood and Portage, the ground sank by 8 feet. They had to rebuild roads higher so they wouldn't be flooded by the tide. A huge 27-foot tsunami wiped out the entire village of Chiniga. Many coastal towns were heavily damaged, not just by the earthquake, but also by tsunamis and the fires that followed. After the main earthquake, there were thousands of smaller aftershocks for months. A moderate earthquake of magnitude 4.4 shook Los Angeles in August 2024. Once it was over, the LA Fire Department checked around the city and didn't find any major damage or anyone hurt. In the nearby city of Pasadena, which is close to the earthquake's epicenter, a water pipe burst inside City Hall and everyone had to leave the building. Thankfully, there was no danger of a tsunami. The best we can do to avoid panic in such situations is to be prepared. Japan is one of the places on Earth where earthquakes happen the most because it sits on the edges of 4 tectonic plates. Around 1,500 of these earthquakes each year are noticeable. Because of this, the people in Japan have learned to live with earthquakes. The 1950 law set a rule that buildings should be able to handle earthquakes up to a magnitude 7 without falling apart. An update 30 years later said that buildings should only have minor damage in such earthquakes and still work as usual. But if an earthquake is even stronger, the law says the building's main job is to not collapse and save people's lives. At the most basic level, buildings are made stronger with thicker beams, pillars, and walls so they can handle shaking better. Another technique is placing special pads made from materials like rubber at the base of a building. Some buildings are even built on thick layers of padding that separate them from the ground completely, which helps protect them during an earthquake. A skyscraper might sway back and forth a lot, moving up to 5 feet. To stop it from getting damaged, engineers can add something called dampers every second floor all the way to the top. These dampers are like giant bicycle pumps, but instead of air, they're filled with liquid. When the building shakes, the dampers push against the liquid inside them. Even though the liquid doesn't squish very much, it can still absorb some of the shaking. When they're building tall skyscrapers, engineers try to make the structure as simple and balanced as possible. This means having each floor the same height and placing the support columns evenly. But sometimes, architects who design skyscrapers don't want to make these compromises because they have creative ideas for how the building should look. Then they have to find compromise solutions. For example, Tokyo's Skytree Tower, one of the tallest buildings in the world, is designed in a futuristic style but also includes special features to protect it from earthquakes. It has a central pillar, like in traditional Japanese pagodas, and seismic dampers that help absorb the energy from an earthquake, keeping the building safe.
For hundreds of years, people in the US have reported hearing strange, loud booms. These mysterious sounds are called skyquakes. And yep, it's a real thing. If you've ever heard a loud, distant booming noise that definitely wasn't a thunderstorm or a car engine backfire, congrats, it looks like you've experienced a skyquake yourself. People report them all around the globe, from the US to India and Japan. They go under different names, and we still don't know why exactly they happen. Sometimes these booms come together with earthquakes. People heard them during the New Madrid earthquakes in the early 19th century and up until January 2020. Those who've experienced them describe skyquakes as a rushing or rolling noise. Famous American writer James Fenimore Cooper described it more poetically as the lake speaking to the surrounding hills, which send back the echoes of its voice in accurate reply. Sometimes these mysterious booms happen in cold weather instead of during earthquakes. One of the skyquake hotspots is near Lake Seneca in New York. They call them the Seneca Guns. The booms can be so loud that they shake windows and doors. Back in August 1886, after an earthquake in Charleston, people heard these noises for several weeks, happening at the same time as many aftershocks from the earthquake. In 2020, scientists from the University of North Carolina looked at old news pieces, especially from North Carolina, where people have often reported these sounds. They hoped to match the noises with earthquakes data, but they didn't find any link between the sounds and earthquakes. One of the researchers said they believe the noises are happening in the air, not underground. The team looked at infrasounds, which are low-frequency noises that humans can't hear. They found signals lasting 1 to 10 seconds that matched the times when people reported hearing the booms, but nothing is certain here. Some people think that solar flares, underwater tsunamis, or caves collapsing under the sea cause skyquakes. Others believe the sounds come from planes making loud sonic booms. But that doesn't explain old records of skyquakes from the past before planes were even invented. Some scientists think a type of meteor called a bolide causes these booms. These meteors blow up when they hit Earth's atmosphere. If this happened above thick clouds, the sound would get louder and travel far, but we wouldn't find anything on the ground. Another idea is that gas might be escaping from the bottom of deep lakes, like Lake Seneca. If you think skyquakes are bizarre, let me introduce you to fog bows. They also go under the name of white rainbows, ghost rainbows, or cloud bows. They form in a similar way to regular colorful rainbows, but are much wider. Rainbows happen when there are big raindrops in the sky, and you can always spot them on the opposite side of where the sun is shining. Fog bows are made by tiny droplets in fog, or clouds, instead of big raindrops, and they also appear opposite the sun. If you want to see a fog bow, you need to look for it in a thin fog when the sun is bright. You might catch one when the sun starts to shine through the fog, or if you're near the ocean where fog often forms. Because the water droplets in fog are so tiny, fog bows don't have bright colors like rainbows. They might even look all white, or just have faint colors. Some fog bows are hard to see at first, because they blend into the mist. But once you spot them, they're easy to recognize. The next rare weather phenomenon you gotta watch out for is thunder snow. You guessed it right, it's a special type of thunderstorm that happens during a snowstorm. Unlike regular thunderstorms that often strike in the spring and summer, thunder snow is much rarer because it happens in the strongest winter storms, like big blizzards, and at the same time needs warm air, which isn't a frequent combo. So, for thunder snow to happen, there needs to be moisture in the air, some instability, and something to lift the air, like rising winds. Just like in normal thunderstorms, lightning can appear when you hear thunder. Thunder snow lightning usually goes from cloud to cloud instead of hitting the ground, and the thunder sounds different too, more like a low rumble instead of a loud boom, because the snow muffles the sound. You aren't so likely to get struck by it, but it's still important to stay inside when you hear thunder to stay safe. Northern Lights fans, this one is for you. Scientists noticed a new kind of glow in the sky that looked like a purple streak. They nicknamed it Steve as a joke, but later gave it a more scientific name: Strong Thermal Emission Velocity Enhancement, Steve for short. Steve is actually a fast-moving stream of super hot gas that always moves west and only shows up before midnight. They wondered if something like Steve could happen after midnight, but moving in the opposite direction. And now, scientists think they found the anti-Steve by looking at data from a research station in Norway. In December 2021, they took a picture of a bright purple streak stretching for 620 miles in the sky, and it only appeared after midnight. Satellites from the European Space Agency also measured the conditions in this part of the sky and found that the ions were moving eastward. Steve's late-night twin hasn't been officially named yet, but it would be cool if it was called SAM, which is short for Steve After Midnight. If you've ever seen snow on a sunny day when falling from the sky without a single cloud, it must have been diamond dust. It's a special kind of weather with millions of tiny ice crystals forming close to the ground. These ice crystals float slowly in the air, kind of like how dust floats in your house. When sunlight hits these crystals, they sparkle like diamonds. Unlike regular snow, diamond dust can fall from a cloudless sky, which is why they sometimes call it clear sky precipitation. It happens because of temperature inversion. Normally, it gets colder as you go higher up from the ground. But in a temperature inversion, the cold air stays near the ground, and warmer air sits above it. The warm air has more water vapor, and when it mixes with cold air near the ground, it turns directly into ice crystals, and diamond dust is born. For this to happen, the air near the ground has to be really cold, way below freezing temperature. Diamond dust can fall for days, but it's so light that it usually doesn't pile up on the ground like regular snow. A fall streak hole, also known as a hole punch cloud, is next on our list. This big circular or oval-shaped gap sometimes appears in certain clouds. These types of clouds float high up in the sky and are often made of tiny water droplets that are colder than freezing, but they haven't frozen yet. These special water droplets are called supercooled, and they need a reason to freeze. Ice crystals give them that reason. When a plane flies through the cloud, it can bring those ice crystals into the cloud. Once the ice crystals are there, the supercooled water droplets freeze quickly, get bigger, and start to fall from the ground. This creates a hole in the cloud, and as more nearby droplets freeze, the hole gets bigger and spreads outward. Any tornado is scary, but a fire tornado takes the horror to a new level. These bad boys are spinning towers of flame and ash that form when there's extreme heat, strong winds, and uneven ground. The intense heat from the fire causes hot air to rise quickly. Cooler air from the sides rushes in to replace it and creates strong winds. When winds from different directions meet, it makes the fire spin like a tornado. It gets stronger and can even create its own weather. It pulls in flames, ash, dirt, and anything in its path. The winds can reach speeds of over 140 miles per hour, and these fire tornadoes can last for more than 20 minutes. There's something really bizarre going on at these 12 points scattered across the Earth. The vile vortices, as they're called, are these creepy spots over the Tropic of Cancer, the Tropic of Capricorn, and the North and South Poles, where weird forces seem to take over. You've probably heard of the most famous one, the Bermuda Triangle. It's believed that more than 50 ships and 20 airplanes have mysteriously disappeared in this area, which is located between Florida, Bermuda, and Puerto Rico. But what most people don't realize is that the Bermuda Triangle actually has 11 siblings, and these other spots can be even more terrifying. Let's start with Mohenjo-Daro. This was a thriving city located in what is now Pakistan. Built around 2500 before the Common Era, this urban center was once home to about 40,000 people. But then, suddenly, people abandoned it by the year 1700 before the Common Era. In the 1940s, an archaeologist discovered 39 human skeletons at the site, which fueled the theory that the city was invaded by some other civilization at some point. But honestly, it's hard to confirm that, since archaeology doesn't really explain the city's sudden destruction or the disappearance of its people. It's led to a bunch of bizarre theories. One of them talks about an ancient extraterrestrial race that might have lived there, and a malevolent wind that swept through the city. Another ancient city with a similar mystery is the Great Zimbabwe. Its construction began in the 11th century, and at its peak it housed up to 18,000 people. But for reasons we'll probably never fully understand, it was abandoned in the 15th century. Archaeologists were really interested in this place, and that's when things got even weirder. They found 8 of these birds, now called the Zimbabwe birds. These soapstone sculptures were found sitting on stone columns that were over 90 centimeters tall. Nothing like them has ever been found anywhere else, and their meaning is still a total mystery. Some think each bird represents a new king, but other theories suggest they were ancient animals very dear to the people who lived there. Adding to the mystery, local legends talk about a strange, short man who's sometimes seen wandering around, but he always disappears before anyone can get close. Then there's Easter Island, another one of the 12 vile vortices. It's located in the eastern Pacific Ocean, and it's famous for its nearly 1,000 enormous statues called moai. We still don't know what they mean, or how they were made. Some of them are almost 30 feet tall and weigh as much as 80 tons. Today, it wouldn't be that tough to move and carve these statues, but we're talking about a period between the years 1100 and 1680. So nobody really knows how they did it. Some specialists believe these statues were carried across the island, while others think they were pushed on log rollers. But the most bizarre theories suggest extraterrestrials were involved. Algeria is another land rich in ancient mysteries, and one of the most fascinating is something called the Jeddars. These are 13 monuments with square stone bases and angular mounds, built between the 4th and 7th centuries. But the weird part is, no one knows their purpose. One of them had an inscription in Latin, but it was so worn down that the message was nearly impossible to read. The best guess so far is that these monuments were probably tombs for royalty, although no one knows exactly who was supposed to be buried there. What we do know is that there are many myths related to strange disappearances in the region. The next mysterious spot is located south of Tokyo in the Pacific Ocean, and it's called the Dragon's Triangle. Does that name ring a bell? Yep. Just like the Bermuda Triangle, this area is known for strange disappearances of airplanes and ships. One of the most chilling stories dates back to 1945, when a plane allegedly vanished. The pilot supposedly sent a radio transmission right before the aircraft disappeared, claiming that something strange was happening in the sky, like it was opening up or something. While this story is definitely eerie, the truth behind it and many other Dragon's Triangle legends is still up for debate. If you type Hamakulia volcano into Google Earth, you'll find it located in Hawaii's Ring of Fire. But this place is so shrouded in mystery that it's hard to find much information about it. Some legends speak of unusual electrical energy being detected in the area, and there's even a story about an eyewitness who claimed to see a plane flying over it totally disappear from the radar. Another eerie spot is the South Atlantic Anomaly, which is an area on Earth where natural radiation flows out of control. While this doesn't affect our daily lives on the surface, it has a pretty big impact on Earth's atmosphere. The radiation there is so intense that it can knock out the onboard computers of spacecraft and interfere with the data collected by satellites passing through the area. To deal with this, specialists had to add an additional shield to the International Space Station. The South Atlantic Anomaly is also linked to a weird event that astronauts experience called cosmic ray visual phenomena. They've reported seeing random flashes of light or shooting stars out there in space, but it's all just some kind of illusion. From wild radiation to strange seismic activity. The Wharton Basin in the Indian Ocean is a place known for unusual tectonic events. In April of 2012, a massive earthquake measuring magnitude 8.6 hit the region. This was considered the largest intraplate earthquake ever recorded, meaning it happened within a tectonic plate rather than at its boundary. This caught the attention of scientists, who now speculate that the region might be forming a new boundary between the Australian and Indian plates. But for now, this is all still one big mystery. Now let's head to the Pacific Ocean, more specifically to the New Hebrides Trench. This submarine trench is about 750 miles long and 45 miles wide. It formed when the Australian plate slid under the New Hebrides plate. There's no doubt that this is one of the creepiest and deepest spots in the ocean. The danger isn't just down in the deep sea either, as this trench has been connected to several earthquakes that affected New Caledonia and Vanuatu. This area also has some strange features. For example, when scientists explored it, they didn't find a single grenadier fish down there. This type of fish is one of the most common deep-sea creatures you would expect to see in trenches around the Pacific. So why aren't they around the New Hebrides Trench? Maybe they know something we don't. The two remaining vile vortices are the North and South Poles. These two are on the opposite ends of the planet, but they share one thing in common: strange disappearances. One of the most famous stories from the North Pole happened in 1897. 3 brave explorers set out on a journey to reach the North Pole using a hot air balloon. But they never completed their mission. Their mysterious disappearance remains one of the most intriguing, unsolved mysteries in the history of Arctic exploration. The South Pole is also known for similar mysteries. It's believed that hundreds of people may be buried beneath the snow and ice of the coldest continent on Earth. Even with all the advancements in technology and knowledge, the South Pole can still be extremely dangerous for anyone who ventures there. The temperatures can drop to almost minus 130 degrees Fahrenheit, and the winds can get up to 200 miles per hour. And that's definitely enough reason to stay away. Now that you're familiar with the 12 vile vortices, let me tell you something even stranger. If you look at a map, you'll see that these places are arranged in a way that looks pretty similar across the globe. Here's the weird part. If you connect these spots where unexplained events have occurred, you actually form the geometric shape of an icosahedron. This could be just a huge coincidence, but the fact that these mystery spots align with this shape makes them even more intriguing.
The strongest earthquake ever to strike east of the Mississippi River that happened over 200 years ago was never over, according to some scientists. Most earthquakes last seconds to minutes, and the official record breaker so far is a silent one in Sumatra that was going on for 32 years. This slow slip event triggered a massive quake and a tsunami. So if it's true that the New Madrid earthquake is still sending aftershocks, we'll have a new top name for this sad list. The earthquake started in December of 1811 with a powerful quake in a sparsely populated part of northeast Arkansas. They felt the shaking almost 1,000 miles away in the White House, and the tower bells were ringing in Boston, even further away. It even made the mighty Mississippi flow backward for a few minutes over new waterfalls formed by shifted ground. The town of New Madrid, Missouri, completely disappeared in the disaster. The Earth wouldn't stay still until the end of January the following year, when things got serious again. A massive quake hit, this time near the junction of the Ohio and Mississippi rivers, right in the Missouri boot heel. Geologists believe it was a rupture on the New Madrid Fault, putting even more strain on the nearby Reelfoot Fault. Just when people thought it couldn't get worse, another 2 weeks of trembling passed, and the Reelfoot Fault snapped deep beneath New Madrid. Down in Tennessee, about 15 miles south of New Madrid, the ground uplift created Reelfoot Lake. Steamboats were chugging along the river, with thousands of trees floating and acres of woods torn apart by the quake. In St. Louis, Missouri, which is 160 miles away, buildings were badly damaged, and chimneys fell in Cincinnati, Ohio, 400 miles away. People all the way in Montreal, Canada, over 1,000 miles away, felt the earthshake. Seismologists have registered about 200 small earthquakes in the New Madrid seismic zone every year since 1974. Some researchers believe that up to 30% of those were aftershocks from those big quakes back in 1811 and 1812. In parts of the U.S. where there's not much tectonic action going on, these aftershocks could keep rumbling for years, maybe even centuries, after the big ones hit. Aftershocks are the Earth's way of releasing all that built-up stress from the main quake. When the ground shakes from the first earthquake, It puts a lot of pressure on the rocks nearby. And when those rocks can't take it anymore, they crack, causing even more shaking. That's the aftershock. And they can be pretty intense, especially right after the main quake, but weaken over time. Not all scientists agree that contemporary earthquakes have to do with those from 200 years ago. We mostly associate faults with those lines where Earth's plates meet. But there's a whole network of those right under the center of the North American plate. They're like relics from 750 million years ago, when North America was part of a supercontinent called Rodinia. When Rodinia started to break up, it left behind these rifts, weak spots in the Earth's crust that run deep beneath the modern Midwest. It could explain the earthquake action. An international team of geologists decided to take a fresh look at 3 major earthquakes that shook North America and end the debate. They used a new math method called the nearest neighbor. It says that if earthquakes are too close in space, time, and magnitude to be independent background events, then one is assumed to have triggered the other. Depending on how you look at the numbers, somewhere between 10 to 65% of the recent quakes in the region could be aftershocks of those historic earthquakes. And a huge quake that hit Charleston, South Carolina at the end of the 19th century might explain up to 72% of the earthquakes in the area since then. But not all places are the same, so the scientific debate continues. In 1774, British explorer James Cook noticed a glow in the distance. It was the volcano of Mount Yasur in Vanuatu. This bad boy had been spewing lava and ash ever since, and is quite likely that it's been doing that for way longer. The volcano has been sitting at alert level since October 2016, which means things are really unsettled around there. They've even marked off a 2,000-foot radius around the crater to keep people safe. There have been low to moderate outbursts, shooting out ash, gas, and steam, and some bigger blasts throwing stuff outside the crater. Satellite images have picked up on some hot spots of sulfur dioxide plumes, showing that Yasur is still cooking up a big storm down there. Stromboli, one of the volcanic islands near Sicily, officially has the Guinness World Record as the longest continuously erupting volcano. It has been putting on a fiery show for over 2,400 years straight. Ancient sailors nicknamed it the Lighthouse of the Mediterranean. Most of the time, Stromboli's just spitting out spatter, but every now and then it throws in some lava flows or shoots up some moderately high fountains. Sometimes you might even catch a glimpse of steam-driven outbursts. Over 200 million years ago, the world went through a major makeover, with not one, not two, but 4 massive volcanic eruptions changing the game. It all happened in Rensselaer, a large chunk of island that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in China to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels, making the atmosphere toasty and the rain pouring down. It all happened in 4 separate pulses, each triggered by those monstrous volcanic blasts. There's a spot in a national park not too far away from Sydney, Australia, where a fire has been raging deep underground for at least 6,000 years. They call it Burning Mountain, and it's a coal seam fire, burning its way through a layer of coal beneath the Earth's surface. Once these underground fires start, they're pretty much impossible to put out. This ball of fire is up to 30 feet wide and extremely hot, but there's no flame, it's smoldering. The fire has been creeping along at a pace of about 3 feet per year. A local farmer first spotted it in the 19th century and thought it was a volcano. The people who have lived here for ages believe this place is sacred. They've used it for cooking and crafting tools, and tell that it started from a widow's tears or the torch of a hero. but experts think it could have been a lightning strike or coal heating up like a summer barbecue from the interaction with oxygen. Some say it might have been burning since before the dinosaurs roamed the Earth. No one knows exactly how long this mountain will burn or in what direction it'll move. Right now, the coal has enough oxygen to burn for centuries or even millennia without human intervention. The fire is heating up the mountain like a giant oven, making it crack and crumble, inviting in more oxygen to feed on. Even if humans decide to take action, these coal seam fires need truckloads of water and liquid nitrogen to tame them. Several years ago, explorers noticed that the smolder was creeping close to a cliff overlooking a little river. And depending on what the coal seam decides to do next, we could see some dramatic changes here in the coming decades. There could be flames with much more heat, or the coal seam could go deep, extinguish itself, and smolder out. Okay, it's pop quiz time. What's the strongest river in the world? The Amazon? Pfft, rookie guess. No, really. The mightiest river isn't on land at all. It's underwater, and it's called the Antarctic Circumpolar Current, or ACC for friends. This beast flows with a force 100 times stronger than the Amazon River, and it could power over 100,000 hydroelectric plants. That's enough electricity to light up entire continents. But this underwater juggernaut doesn't just flex its muscles for fun. It's the planet's ultimate multitasker. The ACC is Earth's thermostat, carbon vacuum, climate stabilizer, and oceanic superhighway all rolled into one. But here's the not-so-fun part. Scientists have spotted a serious red flag. The ACC is slowing down. And not just by a little bit. We're talking up to 20% weaker by 2050. If this trend continues, we're looking at climate chaos that could make your worst Monday feel like a day at the spa. So, maybe time to panic a little? Well, hold on. So what is the ACC anyways? To learn more about it, we need to dive deep into the ocean, figuratively. The Antarctic Circumpolar Current is the only ocean current that flows all the way around the planet, hugging the cold continent of Antarctica like a belt of water. Unlike other currents that get tripped up by continents, the ACC has a clear racetrack, nothing but open ocean, so it flows uninterrupted through the Drake Passage between South America and Antarctica. It moves an astonishing 3.6 billion cubic feet of water per second. That's so much water we couldn't find anything to compare it to, sorry. The ACC is driven by ferocious westerly winds, moving eastward to connect the Atlantic, Pacific, and Indian Oceans into one continuous supercurrent. It also plunges into abyssal depths, connecting shallow, intermediate, and deep waters into one giant, swirling blender of oceanic energy. Now, to put it simply, maybe too late for that, but I'll try, the ACC is the glue that is keeping all of our planet together. It plays a starring role in the thermohaline circulation, or global conveyor belt, if you don't want to sound lame. This is the system that redistributes heat, carbon, and nutrients around the globe. To make it all work, the ACC pushes nutrient-rich deep water to the surface in a process called upwelling, feeding plankton, krill, whales, and eventually sushi on your plate. That means if you love seafood or care about ocean food chains at all, you should really start paying attention. Without this nutrient cycling, marine life from the bottom to the top of the food web suffers. Now, here's the cool part. While it's busy playing waiter to the sea, the ACC is also doing our laundry. Well, sort of. It absorbs massive amounts of carbon dioxide from the atmosphere and stores it in the deep ocean, locking it away for centuries. Think of it like Earth's giant carbon vault, no password required. It also helps regulate the weather. Without the ACC pushing heat around the globe, Western Europe would be 50 degrees colder. That means Paris would feel like Siberia, and Londoners would have to trade their umbrellas for snowshoes. The current helps maintain the temperature balance between the hemispheres, stabilizing wind patterns, rainfall, and ocean temperatures around the world. Even hurricane patterns could change because warm ocean surfaces are a key ingredient for cyclone formation. Mess with the currents, and you might be dialing up stronger, weirder storms. So, Why is it slowing down? Well, of course, the answer is humans. You know those ice caps that are melting? Well, in Antarctica, where our friend the ACC lives, there's so much ice that if all of it melted, the Earth would rise more than 200 feet. That's taller than Cinderella's castle. What's worse, 60% of all the fresh water in the world is frozen in that ice. While that much water melting is already terrifying, it's the freshness of the water that really messes things up. You see, the ACC relies on the Southern Ocean's cold, salty water to be dense and heavy so it can sink, which helps power the current forward like a chain reaction. But when fresh water from melting glaciers pours into the ocean, it dilutes the saltiness. That makes the water less dense, so it stops sinking properly. Without that sink and flush mechanism, the ACC can't maintain its powerful flow. It's like trying to flush a toilet with no gravity. As this continues, fresh water flows north, altering the ocean's density structure and counteracting the effects of ocean warming, which normally would speed the current up. Instead, the ACC slows down. A weaker ACC means less upwelling, so fewer nutrients reach the surface. This could devastate Antarctic marine ecosystems, reducing biodiversity, collapsing fisheries, and threatening species like penguins, whales, and krill. It also opens the door in Antarctica to invasive species, like the southern bull kelp, which could throw entire food chains into chaos. Krill alone are the main food source for whales, seals, penguins, and fish. So when krill populations crash, the whole system begins to wobble like a house of cards in a hurricane. And then there's the feedback loop from hell. As the ACC weakens, more warm water can sneak southward, reaching Antarctica and melting the ice even faster. That melting will dump more fresh water into the ocean, which will weaken the current even more, which will melt more ice, and you get the idea. It's a vicious cycle. Worse still, warm waters underneath ice shelves can cause them to break apart from below, meaning the melting accelerates even when surface temperatures seem stable. Globally, the effects would ripple far and wide. Monsoons in India could become erratic, rainfall in the Amazon could drop, and agriculture from Africa to Asia could suffer. Sea levels along the east coast of North America could surge, and global weather patterns could spin into confusion. Even the Southern Ocean's ability to support commercial fisheries, like Chile's lucrative salmon industry, could decline as nutrients fail to reach the surface. And let's not forget, without a strong ACC, the ocean's ability to absorb carbon and excess heat plummets. That means that more CO2 and heat will stay in the atmosphere, making our lives even more miserable. It's like turning off Earth's air conditioner while cranking up the furnace, and burning down the pantry while you're at it. Of course, this isn't the first time things went south with the ocean currents. Before humans started heating up the planet, Earth went through a deep freeze called the Little Ice Age, and it wasn't just about colder winters. This icy chapter may have kicked off when ocean currents in the North Atlantic started acting weird. And it wasn't so long ago. This Little Ice Age had a peak in 1850, literally yesterday. Scientists believe that melting glaciers and massive exports of Arctic sea ice flooded the ocean with fresh water. That fresh water messed with the ocean's usual saltiness and density, weakening powerful systems like the AMOC, short for Atlantic Meridional Overturning Circulation. That's a mouthful. It's another crucial piece of the global conveyor belt puzzle. As these currents slowed down, less warm water reached the north, sea ice spread farther, and temperatures dropped even more. And here's the spooky part. Records from seashells near Iceland showed that this shift didn't happen all at once. It came in two waves, like the planet was struggling to stay stable before tipping into a colder world. And because the AMOC is also part of the crazy life support system of planet Earth, everything is connected. Both systems are influenced by temperature, salinity, and the sinking of cold water. When the ACC slows, it can alter the balance of deep water formation and mixing, potentially weakening the AMOC too. That's a domino effect you really don't want to see. In fact, some models suggest that if both the ACC and AMOC are pushed past their tipping points, The result could be centuries of unstable climate conditions, way beyond anything modern agriculture or infrastructure is built to handle. So, next time you're sipping a cold drink or enjoying sushi, maybe raise a toast to the mighty ACC. It's doing a lot more for you than you think, and it could really use a little appreciation and less ice melting, please.
How would you describe the shape of the planet we live on? It's definitely round, but it's not a perfect sphere. Because of the force of Earth's rotation, it's slightly flat on the north and south pole. But there's more to it. The planet's rotation causes its sides to bulge outwards. The best term to describe our home planet is ellipsoid. Earth is nothing more than an oversized lumpy potato. These are the words of Atraji Ghosh, a solid Earth geophysicist from Bangalore. She and her team have been studying something called the Indian Ocean Gravity Hole. Sounds like the scenario for a science fiction movie, but it's very much real. We think of gravity as something consistent. If you drop a pen from your hand in Los Angeles and in Perth, they're going to fall to the floor at the same time. Well, this is not completely true. Gravity is connected with the mass of a celestial body. Astronauts on the surface of our moon don't walk, but move in hops. That's because Earth weighs 81 times more than the moon. Less mass means less gravity. Earth is more massive, so it has a stronger gravitational pull. But there's a catch. All this mass isn't distributed evenly across the planet. As a result, gravity varies as well. NASA has been mapping Earth's gravity field since 2002 using twin GRACE satellites. The maps they produced show where gravity is stronger and where it's weaker. Mountain ranges such as the Himalayas contain a lot of mass. This means they generate a stronger gravity field. The opposite happens in ocean trenches. The deepest of them is the Mariana Trench in the Pacific Ocean. You could almost stack 2 Mount Kilimanjaros inside it. The low concentration of Earth's mass below it means that the gravity field here is weaker. Places on the globe where huge chunks of mass are missing are called geoid lows. A geoid is an imaginary surface that follows the outline of sea levels around our planet. Imagine the Earth without any land. That shouldn't be too hard since the nickname of our home is Blue Planet. Now draw a curvy line along the surface of the oceans, and you get a geoid. In reality, the line stretches across oceans, as well as land masses. Scientists use this imaginary line to calculate the depth of tremors or objects that occur underground. When the wavy line goes down, that's a geoid low. The biggest of them sits at the bottom of the Indian Ocean. The first to discover it was a Dutch geophysicist in 1948. He was performing a gravity survey from a ship. The man noticed that sea levels dipped over 320 feet below the global average. The gravity hole got the official name Indian Ocean Geoid Low. It spans well over 1 million square miles off the southern coast of India. If you went out at sea in the middle of the gravity hole, you wouldn't notice much, just an endless ocean as far as the eye could see. The only way to measure the dip in gravity is through extensive geophysical measurements and calculations. The concept of a gravitational hole existed for nearly 2 centuries in the scientific community, but researchers could study it in high detail only after satellite measurements became possible in the late 20th century. A team of Indian scientists was determined to explain the anomaly that had been puzzling geologists for decades. They used supercomputers to simulate the seismic activity that formed our planet. A total of 19 simulations revealed how tectonic plates moved across the span of over 140 million years. This was during the Cretaceous period, the time when T-Rex roamed the Earth. Nearly a third of the possible scenarios produced a geoid low, similar to the one in the Indian Ocean. The most important factor in these models was the presence of magma plumes. These are places inside the Earth's mantle where lava flows upwards. The mantle sits between the planet's outer core and the thin crust we walk upon. The magma in the mantle plume is hotter than the surrounding rocks. The heat it generates melts and thins the crust. This creates hotspots that are brimming with volcanic activity. Yellowstone National Park and the Hawaiian Islands sit atop such hotspots. The Indian team of scientists linked the presence of magma plumes to the formation of the geoid low. Their source was an ancient ocean that disappeared tens of millions of years ago. It was located where the Himalayan mountain range sits today. Evidence of this lie in the marine rocks researchers found on the world's tallest mountains. The oceans ceased to exist when India's landmass separated from the supercontinent called Gondwana. It drifted north and merged with the rest of the Asian continent. At the time, the Eurasian supercontinent was called Laurasia. The Indian tectonic plate went down inside the mantle. It ended up under the African continent. This landmass contained a lot of crystallized material which was quite dense. When the sinking plate of the former ocean reached it, plumes of magma spilled out. As a result, low-density materials ended up closer to Earth's surface. Density is used to calculate mass, and if you remember our lesson in physics from the beginning of the video, less mass translates into a weaker gravity field. Scientists believe this is how the geoid low in the Indian Ocean formed some 20 million years ago. At this point in prehistory, the Earth looked a lot like it does today. There were vast grasslands, and whales swam in the seas. Geophysicists who created the computer model cannot tell for sure what will happen in the future. Ghosh thinks it's possible that the gravity hole in the Indian Ocean will remain in place for a long time. But plate movements can also cause the anomaly to fully disappear in the coming eons. Earth's tectonic plates are constantly shifting. They define the shape of our continents and oceans. Experts study plate movements to get a picture of how our world looked millions of years ago. However, telling Earth's geologic future is much more complex. The gravity hole in the Indian Ocean is the biggest, but it's not the only one in the world. Other areas with low gravity include the island of Cuba and the Bahamas. On the opposite side of the spectrum are the Philippines. Here, gravity is stronger than normal, but the poles are the places with the strongest pull to them. They are the closest to the center of the Earth. If you stand directly on the North or the South Pole, you are 3,950 miles from the planet's core. At sea level on the equator, this distance increases by more than 13 miles. Earth's gravitational field also has an effect on your weight. At the equator, you weigh 1% less than you do on the poles. The South Pole is maybe more suitable for this experiment because there is actually ground there. But gravity is the strongest at the North Pole in the middle of the Arctic Ocean. This is where scientists in 2013 recorded the highest gravitational acceleration on the planet. This is the rate a falling object speeds up in free fall. The acceleration depends on the strength of gravity. When a team of researchers from a university in Perth set out to map these gravity changes, they discovered something interesting. Gravitational acceleration was the highest at the surface of the Arctic Ocean. This is something they expect to find, but the location of the lowest acceleration point amazed them. It wasn't on the equator as they assumed. The spot lay more than 600 miles south of it at Mount Huascarán in Peru. Scientists believe that the mountain's height had an effect on the phenomenon. This peak in the Andes is the highest point in the South American country. Hypothetically speaking, if a human falls from a height of 330 feet here, they will reach the ground 16 milliseconds later than if they performed the same stunt in the Arctic.
Did you know there's a guy who rode on a wave for 7.5 miles? It was accomplished by Brazilian surfer Picaruta Salazar in 2004. Just for comparison, Central Park in New York extends for a mere 2.5 miles. That was the Pororoca wave, and it can only be surfed for 3 days a year. It's pretty powerful, so it sort of pushes you. But there are definitely some tough spots where it's not that easy to catch waves. If you're looking for the gnarliest surf spot, Pipeline in Hawaii is where it's at. But beware, it's not for the faint of heart. This place is known for its massive waves that can reach up to 20 feet tall. And did we mention the shallow reef? Yeah, wipeouts here can result in some serious injuries, or worse, you might end up sleeping with a fish. The waves at Pipeline are also super unpredictable, so you never know what you're going to get. It's like a box of chocolates, except instead of chocolate, it's huge waves that could crush you like a bug. But hey, if you're feeling brave, the annual Billabong Pipe Masters competition is held there every winter. Just make sure to bring your A game and a change of underwear. Even the most experienced surfers approach pipeline with caution and respect. It's like trying to tame a wild animal. One wrong move and you're toast, or dinner. So, if you're ready to ride the gnarliest waves in the world, come on down to Pipeline. Just don't say we didn't warn you. For those who are dreaming California, there's a tough spot in the Golden State for you. Mavericks is notorious for its massive swells and strong currents, making it a challenge even for experienced surfers. Hold on tight, because this wave is gonna take you for a ride. First off, let's get one thing straight. Mavericks ain't for the weak. This bad boy can reach heights of up to 60 feet. But hey, if you're a seasoned surfer and you're feeling brave, then Mavericks is the place to be. Located just off the coast of Half Moon Bay, this spot is known for its massive swells and killer waves. It's like the Hulk of surf spots, big, bold, and ready to smash. Now, don't go thinking that Mavericks is all about the waves. Oh no, my friend. This spot is also home to some of the coolest surfers around. These dudes and dudettes live for the rush of catching a maverick wave, and they'll do whatever it takes to get out there. But here's the thing, Mavericks isn't just about surfing, it's also about community. These surfers have each other's backs, and they know that when they're out there on those massive waves, they're all in it together. It's like a big, salty family. So there you have it, folks, Mavericks, the wildest, most insane surf spot in California. If you're up for the challenge, grab your board and head on out. Just remember, when you're staring down a 60-foot wall of water, it's okay to scream like a little girl. We won't judge. Chupo in Tahiti also has some of the heaviest waves in the world, breaking over a shallow reef and creating intense barrel rides. First of all, the name itself is a mouthful. It's pronounced Chupo, and it means broken skulls in Tahitian. Yeah, you heard that right, broken skulls. The waves at Chupo are massive and can reach up to 23 feet high and break over a shallow reef, which creates a super powerful wave that can barrel for hundreds of yards. And if you wipe out, well, let's just say you'll be getting up close and personal with that reef. It's like a cheese grater for your skin. So make sure you bring some Band-Aids and a good insurance policy. But hey, if you're up for the challenge, Chupo is one of the most epic surf spots in the world. However, I hope you're going to choose a much safer spot. If you're looking for some cool waves but don't want to risk your life, then you gotta check out these safe surfing spots around the world. First up, we got Waikiki Beach in Hawaii. This spot is perfect for beginners and pros alike, with consistent waves and a sandy bottom. Plus, there are lifeguards on duty to keep an eye out for any trouble. Next, there's Bondi Beach in Australia. This iconic beach is known for its beautiful scenery and chill vibes, but it also has some great waves for surfing. The water is shallow, and there are plenty of surf schools around to teach you the ropes, or in this case, the boards. But if you're looking for something a little more exotic, head over to Nocera in Costa Rica. This spot has warm water, consistent waves, and a laid-back atmosphere. Plus, the locals are super friendly and will welcome you with open arms. Last but not least, there's Muizenberg Beach in South Africa. This spot has some of the most consistent waves in the world, but they're not too big or dangerous. Plus, there are shark spotters on duty to keep you safe from any unwanted attention from local carnivores. But no matter how safe the spot is, you're still going to need some cool life hacks to bring your surfing to a brand new level. Have you ever wondered why surfers use wax on their boards? Well, let me tell you, it's not just for show. See, when you're out there shredding the gnar, you don't want to slip and slide all over the place like a penguin on ice. That's where the wax comes in. Basically, the wax creates a grip on the board so you can stick to it like peanut butter on bread. Without it, but here's the thing, not all wax is created equal. You gotta find the right kind for your board and the water conditions. It's like choosing the right flavor of ice cream for your cone. You don't want to end up with mint chocolate chip when you really wanted Rocky Road. So, next time you see a surfer waxing up their board, Just remember, they're not doing it for the smell, although some waxes do smell pretty sweet. They're doing it so they don't wipe out and embarrass themselves in front of all the folks on the beach. And that's worth its weight in gold. And by the way, did you know that rubbing a little bit of wax on the bottom of your feet can give you a better grip on your board? Yeah, it's like magic. No more slipping and sliding around like a seal on a wet rock. Another common hack is to wear earplugs. You see, there's even a condition called surfer's ear. Surfers are constantly exposed to cold wind and water, and some of them even surf in cold temperatures. If your ears are constantly exposed to cold, your ear canal may shrivel up. As a consequence, water, wax, you, and even air all get trapped in your ear, which may lead to certain infections. So, to prevent water and cold air from getting trapped in their ears, pro surfers like to use earplugs. But even if you're just a newbie, you gotta use their tip. Oh, and here's another classic. If you're surfing in cold water and don't have a wetsuit hood, just rub some petroleum jelly on your ears to keep them warm. Hey, why do you think some surfers have clear nail polish on their emergency kits? It's not for their nails, but for their boards. So, if you're dealing with a stubborn ding in your board, grab some clear nail polish and fill in the crack. It'll keep water from seeping in and causing more damage. However, pros will say that nail polish is a terrible idea, and there are a lot of repair kits out there. Yeah, this one's up to you. So, there you have it, my fellow wave riders. Now go out there and shred those gnarly waves like the pro you are.
Let me take you to a place that seems to be out of this world. Life inside this cave has been isolated from the outside world for about 5.5 million years, and it does show. See for yourself. Due to such a long isolation, the conditions inside the Movil Cave are like nowhere else on our planet. A unique ecosystem is flourishing there, even though there is a severe lack of sunlight inside the cave, and the air is toxic. The cave, located a few miles west of the Black Sea in Romania, was first discovered in 1986. Nowadays, you can only visit it if you have special permission. Plus, the central caverns are guarded naturally by narrow limestone tunnels and vertical shafts. So, if you're no stranger to claustrophobia, you'd probably better not enter this place. In the depth of the cave, the air has twice less oxygen than the air outside. Instead, it contains a lot of carbon dioxide and hydrogen sulfide, so not the freshest air you can breathe. It's also pitch black inside the cavern. But despite, or should I say thanks to, this cocktail of extremely harsh conditions, the site is a true goldmine for biologists. Shockingly, life seems to be booming here. In a 1996 study, scientists identified 48 species, and 33 of them were unique to the cave. Most of the creatures inhabiting the cave are tiny, with long limbs and antennae that help them navigate in the dark. They have no vision and lack pigment, and it makes sense. Why would you need to be able to see if you live in total darkness? And why would you need to be pretty and colorful with no one to see you? Now, I'm going to take you to another cave. It's no less amazing, but looks very different. This is the Giant Crystal Cave, aka the Cave of the Crystals, in Mexico. These ginormous crystals were found in 2000 by a mining company after the water was pumped out of the cave. Two miners then saw the crystals after entering the drying cave on foot. These awe-inspiring crystals are actually massive gypsum pillars hidden 984 feet underground. They're anchored to the walls and the floor of the scorching hot cave. Scientists estimate that the crystals could have been already growing for 500,000 years. That's why many of them are so long and wide that you can walk across them. Unfortunately, visiting this wonder of nature is impossible at the moment. But maybe it's for the better, since the Giant Crystal Cave is a dangerous place that can easily turn into a trap. For tens of thousands of years, it was filled with groundwater, which was originally pushed upward into the opening by a magma chamber located in the depths of our planet. The magma under the cave kept the water hot, but eventually the temperature of the water dipped below 136 degrees Fahrenheit. As a result, the water started to fill with calcium and sulfate, whose particles began to recombine into gypsum. And then, white-tinted crystals took over the cave. And since they stayed underwater, they were able to keep growing. You don't have to fly to space to take a closer look at a black hole. Scientists have found something very similar to black holes in the southern Atlantic Ocean. A black hole has such an enormous gravitational pull that once something gets pulled inside, it doesn't have any chance to escape. Even light can't get out of a black hole. But ocean black holes seem to be almost as powerful as their space relatives. But instead of catching the light, they do the same with water. Ocean eddies are massive whirlpools that spin against the main current. They usually swirl billions of tons of water, and most of them are larger than a city. These whirlpools are so powerful that nothing trapped by them can escape. But the scariest thing is that you might not even notice heading into one of them. These things are so huge that you won't spot their boundaries until it's too late. When scientists started exploring ocean vortices with the help of satellites, they discovered the borders of several eddies. After that, they managed to prove that, mathematically, these whirlpools are the same as mysterious black holes in space. Massive eddies are surrounded by super tight barriers where fluid moves in closed loops. Even water can't get out from the inside of these loops. That's why tight ocean vortices play the role of enormous containers. Water inside them can be totally different from the ocean surrounding an eddy. And I'm not only talking about its temperature. The salt content inside and outside a whirlpool often differs as well. On the thin Curonian spit splitting the Baltic Sea from the Curonian Lagoon, there is one of the most bizarre places on Earth. Locals call this area the Dancing Forest because pine trees in this forest have shockingly unusual shapes. They twist in spirals and circles along the ground. There are some theories why it could be happening, of course. Some people claim that huge amounts of positive and negative energies once clashed in that spot. More down-to-earth individuals believe that the reason is geological. Sandy soil in the area is too unstable to hold trees growing upright. The most popular is the idea that strong winds blowing from the water influence the shape of the trees. In any case, experts haven't come to the final conclusion yet. Look at these underwater crop circles. For the first time, they were spotted in 1995, close to southern Japan's coast. Local divers called these 7-feet-wide structures mystery circles. The enigma had been plaguing many minds for almost 16 years until the culprit was finally caught. Imagine the researchers' surprise when it turned out to be a male pufferfish. The fish needs a bit more than a week to build one circle, and the aesthetics are obviously crucial. A male is swimming inside the circle, digging valleys in the sand with its fins. But that's not all. The fish also use shells and corals to decorate particular parts of their circles. This whole build-a-circle thing has a practical purpose as well. The way a male fish swims pushes the sand toward the center of the circle and creates a mound which later serves as a nest. The next mystery on our list is in the Caribbean. Just off the coast of Belize, there's a giant sinkhole. That's the Great Blue Hole. It's about 1,000 feet across and more than 400 feet deep. Once, a long time ago, this hole was a cave. But then rising waters filled it, making it collapse in on itself. The deeper you'll descend into the Great Hole's crystalline waters, the darker it will become. You'll see tons of stalactite-filled caves there, but entering them is extremely dangerous, unless you want to get hopelessly lost. Once you reach a depth of 50 feet, you'll notice that the water is shimmering. That's the invisible line dividing the sinkhole's salty top from the freshwater abyss. You might want to turn back right now. Who knows what you might come across in the murky depths? There was an old Amazonian legend that told about the river that was so hot that it boiled. And it was believed to be just a legend until Peruvian geoscientist Andres Russo questioned if the river could be real. All experts denied such a possibility. After all, hot rivers do exist, but only in the areas where there are volcanoes. As for the part of the country mentioned in the legend, there are no volcanoes in that region. But Andres Russo was too dedicated to give up. And in 2011, he finally located the river from the legends. The water in it was indeed steaming hot. Its temperature was 186 degrees Fahrenheit, not boiling, but pretty close to this point. But what shocked the researcher the most was the size of the river. One could think that the almost boiling water was the result of the activity of an underwater hot spring. But thermal pools are always small, while the river is 20 feet deep and flows for almost 4 miles. This is the only river of its kind on our planet.
Ever wonder why, despite all our advancements in technology and science, there's a vast expanse of our own planet that we barely know about? Believe it or not, over 80% of our oceans remain uncharted territory. It's as if we've got this massive aquatic playground in our backyard and we've barely scratched the surface. Also, did you know that only about 7% of our oceans have a special tag called Marine Protected Areas, or MPAs? How come this colossal body of water that envelops most of our planet is also among the most vulnerable and misunderstood spaces in the universe? Pressure has a lot to do with it. Our deep ocean is a beast of a place with no visibility, freezing temperatures, and pressure that's so intense that in certain areas it would make you feel like you're having the weight of 50 jumbo jets on your body. No wonder we're having an easier time sending people into space than to the bottom of the ocean. The deeper you go into the waters, the more pressure piles up. But let's not forget we have tech on our side, right? Scientists now use these cool satellite technologies that track the color of the ocean to check how much phytoplankton is there, for example. Why is this important, you might ask? Because these little plant-like critters are actually pretty major players in our big blue oceans. In the grand scheme of things in the aquatic world, phytoplankton is like the bedrock of the ocean food chain. It gives life to almost everything, from the tiny zooplankton, which are animal-like microorganisms, to those colossal, magnificent whales. When these technologies first came around, satellites could get clear images of the ocean faster than a ship could take the same number of measurements in 10 years. But it's not all about looking at the ocean from space. Sometimes you gotta dive in there and see it for yourself. Thankfully, we've come a long way in ocean exploration tech too. We've got things like floats and drifters that ride the ocean currents while collecting data, and a whole fleet of underwater vehicles, some of which are manned, some remote-controlled, and some even autonomous. Remember James Cameron, the guy who made the movie Titanic? He's super into exploring the ocean, and in 2012, he set a record by going down to the Mariana Trench in a vertical torpedo sub. He thinks there's nothing like being in the ocean and experiencing it firsthand. Other companies use a mix of technologies for their ocean explorations. It led them to discover amazing stuff like a deep-sea coral reef near Morocco, the only one still growing in the Mediterranean Sea. They've also discovered new species and documented ones previously thought to live only in the Atlantic. These efforts have convinced local authorities to declare some places as marine parks. As with most scientific areas, the road isn't without its bumps. These expeditions can cost quite a lot, and the lack of detailed maps and data only adds to the challenge. We can't always rely on bathymetric information, meaning the study of the ocean floor, because it's often not available. And that's the tricky part. We need to explore more to know more, but getting the funds for these kinds of projects can be tough when there are so many unknown variables. One particular company's explorations have helped protect nearly 4 million square miles of ocean so far. The data they collect during their expeditions is invaluable. It's used to identify new species, locate vulnerable habitats, and even show where threatened species are being overlooked. Their work helps dismiss excuses from local authorities who claim they lack the necessary information to establish more MPAs. The same company supports a goal known as 30 by 30, aiming to protect 30% of our oceans by 2030. It's a big target, and there's a long road ahead, but ongoing ocean exploration can provide the proof needed to keep more of our oceans safe. We also need to set aside areas for protection and research, even when we don't have all the facts just yet. On that note, some cool scientists have recently stumbled upon a gigantic and mysterious world beneath the Pacific Northwest coast's ocean floor. The best part is, this massive realm of life is pretty much cut off from the rest of the world above, making it like a secret underground club that only the best microbiologists have access to. Picture an active city. Except the city is microscopic cracks in the basalt rocks of our oceanic crust, and its residents are microbes. These tiny creatures aren't like you and me. They don't rely on sunlight or the organic products of land and water ecosystems for sustenance. Instead, they thrive on chemical reactions with rocks and seawater. Scientists call this type of life chemosynthetic, which sounds complicated, but it basically means life sustained by chemical reactions. While this sort of life has been found deep in mines and around seafloor hydrothermal vents, the scale at which these creatures are found under the oceanic crust is unprecedented. It might even be the most extensive ecosystem on Earth. A geomicrobiologist from Denmark was part of the team that made this discovery. He claimed that over 50% of our planet's surface is oceanic crust, which is an average of 4 miles thick. Imagine the size of this chemosynthetic party happening down there. This discovery didn't happen overnight. Since the 90s, scientists have found weird tiny holes in the basalt rocks that make up much of Earth's outer crust. They seem like they might have been made by bacteria. But hey, there was supposed to be no life there. I mean, imagine trying to survive in a place that's hot, deep, dark, dense, and mostly devoid of the organic compounds we need for life. Yet, here they are. In the following years, more pieces of the puzzle fell into place. Scientists found that the oceanic crusts had different conditions at the centers and edges. At the centers, rocks are jam-packed with energy-rich compounds that support these tiny life forms. But by the time they reach the edges, these chemicals are all gone. Fast forward to now, and it's time to put the puzzle together. A microbial ecologist from the University of North Carolina worked on this research and says we now have solid evidence of microbial life in the cracks and crevices of deep ocean basalt. The next question scientists asked was, how far does this life extend? Researchers collected samples of crust from a plate roughly 120 miles off of Washington's coast, drilling deep beneath the ocean's surface. What they found down there was remarkable. The life down there runs on a unique fuel, hydrogen. Yep, in the absence of sunlight, hydrogen provides the energy for all their biological processes. These microbes use hydrogen to transform carbon dioxide into organic matter. This matter and other byproducts, like methane, then fuel other organisms, creating a network of life. Of course, the life down there isn't as complex as the one we know up here. Scientists doubt there will be any multicellular life under the ocean because it's too hot and energy poor. But hey, who knows? This universe under our oceans still has a lot to reveal. This whole thing is significant for many reasons. First, it confirms that life can exist in places without oxygen, which changes our perspective on where we can find life. This makes us wonder if life could exist under similar conditions on other planets, where surface conditions might be too harsh. The implications on Earth are also profound. If a large portion of life exists in the oceanic crust, then our understanding of life on our own planet could be completely changed. This exciting discovery stretches our understanding of life and prompts us to keep exploring the mysterious depths of our oceans, pushing the limits of our understanding. NASA is also in on the whole deep sea exploration project. Why? Shouldn't they be preoccupied with outer space? Because they're hoping to find hints about what the oceans on other planets might look like. NASA specialists are really hopeful that by unearthing underwater secrets, we can solve some of the big questions about space. Plus, they're testing some nifty equipment for future journeys across our solar system.
If all the volcanoes on Earth suddenly erupted together, it'd be loud. We'd also have around 1,500 of these formations bursting at once. Now normally it's just 10 to 20 volcanoes that are active each day. But what would the world look like if they all blew their tops simultaneously? Geologists think it wouldn't be pretty. Even if only the land volcanoes erupted together, it would set off a chain reaction way worse than anything we've ever seen before. The two big problems would be ash and volcanic gases. While the explosions in lava would be damaging for people nearby, the real danger lies in what happens next. A thick layer of ash would cover the planet, blocking out sunlight completely. No sunlight means no photosynthesis, which means crops would fade away and temperatures would drop considerably. And all this ash cloud could remain in our atmosphere for up to 10 years. Now, ash aside, There's also acid rain to worry about. Volcanic gases like hydrochloric acid and sulfur dioxide would mix with the atmosphere and fall back down as acid rain. This type of weather would harm the groundwater and ocean surfaces. Even if humans would find a way to survive up to this point, we'd have no corals and no other sea creatures around. Scientists have seen similar events in Earth's history at a smaller scale. Big volcanic eruptions have been linked to mass extinctions. When Mount Pinatubo erupted in 1991, it cooled parts of the world for 2 years. But the extra carbon dioxide from these eruptions could also heat the planet, the same way we turn our stoves to broil for that extra crispy layer on our casserole. Geologists also mentioned that there's evidence in our atmosphere that stuff like this may have happened in the distant past. During the Cretaceous period, carbon dioxide levels were way higher than today, which made it difficult for marine life to thrive. Who would survive all this? Probably just some extremophiles, these organisms that survive in harsh conditions like hot springs or deep undersea vents. As for humans, we could all lay low in underground bunkers until things clear up, or build multiple space stations that could fit us all. Yeah, right. The chances of all volcanoes erupting at once, though, are very slim. Whew! That's because there isn't one giant source supplying all the volcanoes on Earth. Each one of these openings has its own deposit of magma, except for a few cases where they indeed share the supply. For example, in 1912, Nova Rupta in Alaska erupted alongside another volcano sharing magma. Scientists have also found evidence of magma hiding under volcanic areas, like under the Taupau volcanic zone in New Zealand. This magma can spread out horizontally for long distances, but is still just a local feature. Even if we consider all the magma under Taupau as one system, it's not connected to other volcanic areas like Indonesia or the Philippines. Because the great majority are isolated, volcanoes can't sync up to erupt at once. The magma comes from different processes, like mantle decompression or adding water to the mantle through subduction. There's no way to make all these different volcanoes erupt together because of how tectonics work. Now, that doesn't mean we won't see interesting volcano activity in the future. Take an underwater area near British Columbia, where recently about 200 small earthquakes per hour have been noted. Deep beneath the Pacific Ocean floor, off the coast of Vancouver Island, magma is set to erupt, heating the water so much that it'll bubble like soda. However, this event will likely go unnoticed by anyone other than scientists. The anticipated eruption will most likely happen around 3 miles below the ocean surface. Scientists explain that the earthquakes range from negative to 4.1 magnitude, meaning only those nearby would feel any tremors. This unusual activity gives us a rare opportunity to study how the Earth's crust forms. The magma beneath the ocean floor is estimated to be almost 1,500 degrees Fahrenheit, but will cool rapidly upon eruption and contact with water. This runny rock will solidify upon contact with the seafloor, turning black quickly. This event will be useful for biologists too, who will have the opportunity to study the marine animal's response to any changes, like run! Antarctica, often seen as a vast icy continent, also holds a volcanic surprise beneath its frozen surface. Researchers have identified over 130 under the western ice sheet alone, making it the largest volcanic region on Earth. Most of these volcanoes, about 90, were only recently discovered in 2017. But could any of these Antarctic volcanoes actually erupt? Well, it depends on which volcano we're talking about. While these formations are relatively young in geologic terms, it's hard for scientists to tell if they're still active or not. There are only 2 confirmed active volcanoes in Antarctica, Deception Island and Mount Erebus. The latter, standing tall as the highest peak on the continent, has been continuously erupting since at least 1972. It's known for emitting gas and steam, and sometimes even throwing out rocks in what are called strombolian eruptions. One of its most notable features is a persistent lava lake in its crater, a rare phenomenon due to specific conditions needed to keep the surface molten. For instance, it's fueled by a steady supply of magma from deep within the Earth's mantle. This continuous inflow of molten rock provides the material for the lava lake to exist. It also features low ambient temperatures. Despite its location in Antarctica, Erebus has relatively mild temperatures in its summit region because of the heat generated by the volcanic activity. This allows the lava lake to remain liquid rather than freezing over. Deception Island, another active volcano, last erupted in the 70s. While it's currently not showing signs of imminent eruption, it's being monitored closely for any concerning activity. Apart from these two being confirmed to be active, Antarctica is dotted with fumaroles, openings in the Earth's crust that release gases and vapors. Sometimes these fumaroles can create icy towers reaching heights of 10 feet. What we should focus on is maybe supervolcanoes. They're this type that has the potential to produce the most massive and destructive eruptions. Unlike the typical one, which has a single vent, supervolcanoes have a vast magma chamber beneath the surface, spanning tens or even hundreds of miles in diameter. Their eruptions can have catastrophic effects on the surrounding area and even impact global climate patterns because of the amounts of ash and gases they spill out into the atmosphere. One famous supervolcano is the Yellowstone one, which some say is gearing up for another eruption. It has the capacity to unleash a colossal eruption, spewing over 240 cubic miles of material. As much as we'd like to predict its behavior, volcanoes don't stick to a calendar. On the contrary, eruptions simply happen when there's enough magma beneath the surface. There also needs to be enough pressure for the magma to travel upwards. As far as we can measure, these conditions are not currently met at Yellowstone. Sure, many volcanoes operate on a cyclical pattern, but that doesn't mean Yellowstone is overdue. In fact, Yellowstone has had just 3 major eruptions over the past 2.1 million years. Also, the term supervolcano refers to the formation's size, not necessarily how fussy it is. Yellowstone's monitoring is extensive, tracking seismicity, ground deformation, thermal emissions, gas, water chemistry, and surface changes. Signs of an eruption would include thousands of earthquakes over a short period. We'd also see deformation on the ground and weird gas emissions ahead of time. Stable, as it might look like for now, the consequences of it having a major eruption could look ugly. Ash dispersion could blanket a 500-mile radius, potentially disrupting Midwest agriculture and clogging waterways. Ash and gas emissions into the stratosphere could induce global climatic effects, making our planet colder for several years. And yes, we've seen some research that it shows there's more liquid molten rock under the Yellowstone volcano than scientists believe. But that doesn't translate to imminent danger.
A tsunami can travel unnoticed in the deep waters at the speed of 500 miles per hour, crossing an ocean in less than a day. When it approaches land, a tsunami will slow to about 20 miles an hour and begin to grow in height. Most of these waves are less than 10 feet high when they hit land, but they can reach more than 100 feet high, about 2 times as tall as the Hollywood sign. When a tsunami comes ashore, areas less than 25 feet above sea level and within a mile of the sea are in the greatest danger. But sometimes, tsunamis can go 10 miles inland. If you're by the coast and feel a strong earthquake, especially one that lasts for more than 20 seconds, that could be a major red flag that a tsunami is on the way. Keep an eye out for sudden changes in the sea level. If the water suddenly recedes way further back than usual, exposing normally submerged areas, that's a sign that a tsunami might be on its way. Plus, if you hear a roaring sound coming from the ocean, like a freight train or a jet engine, that's another ominous sign. And pay attention to any unusual animal behavior. Animals have been known to sense danger before humans did, so if you see birds or marine life acting strangely, it's time to take notice. If you receive an official tsunami warning from authorities, whether through sirens, radio, TV, or mobile alerts, don't ignore it. Take immediate action. If you're in a tsunami-prone zone and experience an earthquake, don't even wait for official warnings. As soon as it's safe to move after the shaking stops, head to the nearest elevated area promptly to ensure your safety. Practice evacuation routes before a real disaster. You might have to follow this route at night and in terrible weather. If you know it well, you'll need to do less thinking in an emergency, which can be life-saving. Talk about tsunamis with all your family members. Everyone should know what to do to minimize fear and win some precious time. Don't store your important papers and valuables in low-lying areas. Floodwaters can go really high during a tsunami, so put your documents in waterproof containers on higher ground. After an earthquake, bridges and roads often get damaged or become blocked. Not to get trapped in a car in a potentially hazardous location, walk or run towards safety. Never go down to the shore to watch for a tsunami. If you can see the wave, it means you're too close to outrun it. Most tsunami-prone areas have signs indicating evacuation routes. Look out for white and blue signs marked Tsunami Evacuation Route, or similar instructions to guide you inland and away from danger zones. In urgent situations where evacuation isn't possible, seek refuge on the 3rd floor or higher in a sturdy building. Even better, aim to reach the rooftop of the tallest and most robust structure nearby. It's better than being exposed. A tsunami is not a single wave, but a series of waves with massive amounts of water that can flood for hours. The first wave may not even be the largest. So, remain on high ground, away from the coast until you receive an all clear from the authorities. You're really unlikely to survive a tsunami in a basement below ground level. As it passes over, everything in its wake gets submerged temporarily until the water recedes back to the sea. If you're in a basement during a tsunami, you might get crushed by collapsing buildings or swirling debris. Unless the basement is exceptionally sturdy, waterproof, and equipped with sufficient air supply, it's not a safe option for shelter. If you happen to be out at sea when a tsunami warning is issued for your area, stay put and avoid returning to port immediately. Tsunamis can sneak up on you with rapid water level changes and dangerous currents in harbors and ports, making them unsafe. In large harbors and ports, authorities take charge during tsunami alerts and direct vessel movements for safety. It's important to stay in touch with these authorities and follow any instructions they give regarding moving your vessel. For smaller ports without such organized control, it's a better idea to carefully relocate your boat to deeper waters. If you have a small boat, the best you can do is leave your vessel at the pier and seek higher ground yourself. If a tsunami gets you in the water, find something sturdy like a tree, a door, or a life raft. Grab onto it tightly while you get carried by the waves. Try your best not to swallow any of the water. Tsunamis can pick up chemicals and waste, which won't do you any good. People in life jackets have a higher chance of survival because they will remain on the surface of tsunami waves and can breathe normally. Tsunami waves aren't like ordinary waves, so they aren't suitable for surfing. Tsunamis don't have a face to ride. They're more similar to tides as they rush in and out. They're much larger, faster, and more powerful. So, trying to surf them is not only dangerous but also illegal in many countries. Because tsunamis come from underwater disturbances, like earthquakes, they're even dangerous for submarines. Despite submarines' robust design to withstand underwater pressure, the force of tsunamis can cause damage. Tsunamis also generate strong currents that can mess up a submarine's ability to navigate effectively. In cases of severe tsunamis, submarines may get hull damage, threatening their buoyancy and integrity. Such scenarios can lead to submarines sinking or being carried away by the waves. That's why submarines operating in tsunami-prone areas must be extra careful and equipped to respond swiftly if this sea monster strikes. Scientists still can't predict tsunamis, but they can use their expertise in seismology and historical tsunami data to identify earthquakes likely to trigger tsunamis and issue warnings. They gather crucial data from seismic and water level networks worldwide, which enables them to swiftly assess earthquake characteristics such as magnitude, location, and depth. Utilizing this information, they determine whether an earthquake has the potential to generate a tsunami and decide on issuing tsunami advisories. For regions like the US and Canada, warning center scientists can typically issue preliminary messages within 5 minutes of an earthquake. These messages include alert levels, earthquake details, threat evaluations, anticipated wave arrival times, recommended actions, and potential impacts. On the 26th of December 2004, early in the morning, an enormous earthquake shook up the ocean floor near the Indonesian island of Sumatra. This seismic event unleashed a monstrous series of waves, tsunamis, that spread out across the Indian Ocean, reaching as far as East Africa over the next 7 hours. These waves were towering walls of water, some reaching a height of over 30 feet. When they slammed into the coastlines of countries like Indonesia, Sri Lanka, India, Maldives, and Thailand, the devastation was catastrophic. Over 200,000 people lost their lives in this most devastating tsunami on record. And it wasn't just the immediate impact. Long-term consequences hit hard too. Villages, resorts, farmlands, and fishing areas were destroyed or submerged in salt water along with debris. Japan is one of the most earthquake-prone countries in the world because it's located on top of 4 converging tectonic plates that constantly interact with each other. After a terrible tsunami in 2011, the country started a colossal project dubbed the Great Wall of Japan. With a jaw-dropping price tag of around $13 billion, this wall goes from the north to the south of the country. The goal is to safeguard coastal towns from future tsunamis, buying its people precious time to save themselves. Some locals worry that this towering structure will sever their deep-rooted ties with the sea. They fear losing touch with the ocean's rhythms and cues, which are crucial for spotting upcoming disasters. But for many coastal towns, the wall is a lifeline, giving them hope for rebuilding shattered lives post-disaster. Oh wow, there's a hole in the bottom of the ocean! It seems that the ocean has a leak. But it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythia's oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so, which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia subduction zone, which is a massive fault line off the Pacific Northwest coast. It's a place where 2 pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythia's oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the 2 plates can lock together, which then leads to the buildup of stress. Not that they'll feel bad. In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes and most likely, not small ones. For example, a release of stress in the Cascadia subduction zone could lead to a magnitude 9 earthquake. For comparison, The biggest earthquake we've ever recorded happened in Chile in 1960, and it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found? For example, check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet. They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia, a road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Solin. The site of Solin was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish. Okay, this one kinda looks normal until you raise it to the surface. The goblin shark, Sloane's viperfish, zombie worms. Ugh. Yeah, I hear ya. Let's move on. The seafloor hides things from space too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found, hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae, could also be involved. Whoa, let me get my popcorn!
Back in 2018, the biggest active underwater eruption ever happened, at least the one that we could officially record. Scientists followed earthquakes that struck the area in the western Indian Ocean off Madagascar. Between 2018 and 2021, over 11,000 earthquakes struck a small island called Mayan between Madagascar and Mozambique. The strongest one had a magnitude of 5.9. Until then, this area had been pretty peaceful. There had only been 2 earthquakes recorded over 50 years. Along with regular earthquakes, there were also some unusual seismic hums, like earthquakes at pretty low frequencies, forming deep underground. People couldn't feel those hums at the surface, but researchers around the world discovered them and realized they were related to volcanic activity no one actually noticed coming. Something strange happened. That underwater eruption created a giant skyscraper-sized volcano. This new underwater volcano turned out to be around 1.5 times the height of One World Trade Center in New York, and almost 10 times bigger than the Statue of Liberty. The area where it appeared had been explored in 2014, but it was almost flat, peaceful, and empty back then. Now, there is an actual volcano nearly 8,500 feet below sea level. The volcano gets its magma from a super profound reservoir located nearly 34 miles underground. It's the deepest reservoir of volcanic magma that we know about. The Earth has layers, and the middle one is kinda chunky. It's very much like peanut caramel filling many chocolates have. Research shows there are probably hunks of oceanic crust deep inside the Earth's liquid mantle. They're stuck there, creating large lumps in something that was supposed to be a smooth layer. Our planet has a rigid outer layer. It includes a hot upper mantle and cracked crust. The hot mantle moves and churns all the time, making the crust at the surface move too. This way, the oceanic crust dives into the depths and makes huge magma plumes go up toward the planet's surface. Scientists even found an ancient piece of the Pacific Ocean hundreds of miles underneath China. Those are the old remains of the Pacific seabed from long ago, and they were pulled downward below Earth's surface into the mantle transition zone. This rocky slab that used to be at the bottom of the ocean is made of the crust and some solid parts of the upper mantle. Most of the volcanic activity on our planet happens where we don't even see it, under the surface of the ocean. About 70% of all volcanic activity happens in the oceans, and mostly in the area of the South Pacific, with over 1,100 volcanoes squeezed into that area. Coastal cliffs, mountain changes, soils, and sediments that line valleys. These are only a small portion of the rocks on our planet. Oceans hide so much more deep down below the Earth's surface. In between the Earth's surface and its core is the mantle. It's a warm, thick layer of rock that moves and flows constantly. Some hundreds of miles below, there's a place where diamonds grow. As they form, they go through high temperatures and pressure, after which they eventually freeze. That way, when they arrive at the surface, scientists can explore their structure, find out how they formed, and understand better what's going on in the depths of our planet. Thanks to diamonds, they realized the mantle was very wet, and it possibly contained much more water than all the oceans on Earth. Our planet is eating up its own oceans. As its tectonic plates move, dive, and go beneath one another, they drag huge amounts of water into the Earth's interior. The water beneath the surface of our planet can help with developing magma and lubricate faults, which actually makes earthquakes more likely to happen. Water is actually stored in the minerals. It gets incorporated into the planet's crust when new oceanic plates form. They go through the process of bending and cracking as they grind under other plates, and huge amounts of water then go deep into the crust and mantle. Scientists research an area that's 18 miles under the surface. They realized these zones pull 3 billion teragrams, which is more than 2 billion pounds. Any ocean is like a whole new world. There are incredible sceneries below the surface, magnificent waterfalls, lakes, and rivers. There are thick layers of salt beneath the seafloor, and rivers and lakes form because seawater goes through those layers and dissolves them, creating something that resembles pools. The dissolved salt makes the surrounding water denser. That water then settles there, which eventually forms underwater lakes or rivers. But there are also mountain chains, trenches, canyons. There's a canyon in the Bering Sea with more than 8,500 feet of vertical relief. This makes the Grand Canyon look way smaller than it is, since the underwater canyon is nearly 2,500 feet deeper. Deep parts of the ocean are really cold. The temperature of the water can be about 40 degrees, but at the bottom, water can get boiling hot. There are hydrothermal vents in the seafloor. Those are the hot springs located at the edges of tectonic plates. The water they release can reach a temperature of up to 750 degrees Fahrenheit, but the pressure at such depths is very intense. So intense, no human being can handle it. Still, it's the pressure that keeps the water from boiling. Ocean depth is on average 2.3 miles. Light waves can still enter at 3,280 feet, even though it's in a very small amount. So all the mysteries hidden below that point remain in total darkness. The actual illuminated part of the ocean goes until 600 feet. Even though the sun gives us light, most of our planet is dark all the time. It's all because of the oceans, covering over 70% of our planet. The loudest sound that came from an ocean, and of the loudest sounds ever recorded, came from an ice quake. It was so loud, researchers picked it up by sensors more than 3,000 miles away. There was a seismic activity that made frozen ground break down. The Antarctic ice sheet is bigger than the continental part of the United States and Mexico together. A big iceberg from Antarctica holds over 20 billion gallons of water, which could make a 5-year water supply for 1 million people. Humans can generally drink sea ice, although we can't drink seawater. As time goes by and the ice ages, the brine trapped between ice crystals drains out. That way, ice becomes fresh enough to consume it. If all the ice sheets and glaciers we have on the Earth melted at the same time, the sea level would rise another 260 feet, which is just a little shorter than the Statue of Liberty, the height of a 26-story building. Clams lived long enough to tell us more about ocean's past. Ancient mollusks can live for more than 500 years. To learn more about a tree, you can use its rings to see how old it is. To learn how old a mollusk is, you can examine its rings within the shell and tell. This is also how scientists get information about the ocean, climate, and whatsoever. Clams can help take a look at what happened about 1,000 years ago. The Earth doesn't have 4 but 5 oceans now. The new one, called the Southern Ocean, was officially recognized only a few months ago. It borders the Atlantic, Pacific, and Indian Oceans, so scientists couldn't agree if it's really a new ocean or just part of the colder regions of these 3. We don't only divide oceans on maps. Each has different conditions for unique marine species. For example, the Southern Ocean has leopard seals, orcas, minke whales, emperor penguins, and other animals that live in cold, icy seas. It's also home to krill, small creatures that look like shrimp and are food for many bigger animals that live there. Life on our planet started about 3.5 billion years ago. I wasn't around then. It's still a mystery how and when exactly, but some theories say life could have first emerged in the depths of the ocean. A few years ago, scientists found microscopic tubes and filaments within rocks formed about 4 billion years ago. These rocks are fragments of ancient oceanic crust. Also, these tiny tubes and filaments are similar to microbes that can still be found on hydrothermal vents in deep parts of the ocean. The idea is these living cells found conditions to stay alive in tiny rocky pores inside the chimneys of those vents, and started the amazing adventure of the evolution of life on our planet. A tsunami hitting major cities on or near the Mediterranean Sea and in the northeastern part of the Atlantic Ocean is not a matter of if, but when. It is scary and surreal to think that places like Cannes or Barcelona could suddenly get slammed by a huge wave. But the fact is, European coastlines are in active tectonic areas. Only about 10% of all tsunamis worldwide happen in the Mediterranean, and there have been at least 290 tsunamis in this area since 1600 before Common Era. Despite the relatively low number, this phenomenon has caused numerous devastating disasters throughout Europe's history. Back in 1755, an estimated 8.5 magnitude earthquake with an epicenter southwest of Cape St. Vincent triggered a tsunami that destroyed most of Lisbon, the capital of Portugal. About 40 minutes after the earthquake, this massive wave just slammed into the harbor in downtown, racing up the Tagus River. The phenomenon was so fast that several people on horseback had to gallop to higher ground to avoid getting carried away. And this was just the beginning of a nightmare, with 2 more terrifying waves hitting Lisbon right after. A disaster like this is similar to what we see in the Pacific Ocean several times a century, but in the Atlantic, it's very rare. This type of major tsunami is expected to happen every 3 to 5 centuries, but now it could happen tomorrow. Marseille in France, Chipion in Spain, and other cities are on the list of important locations that could be flooded soon, with a roughly 100% chance of being hit by a tsunami in the next 30 years. Statistics show that the wave will probably be more than 3 feet high. I know, it doesn't sound like much, especially since when we think about tsunamis, we imagine terrifyingly tall waves, like the one that hit Lituya Bay in Alaska. In that case, the wave was over 1,700 feet tall. But we must remember that even waves only 19 inches high can be dangerous to swimmers. Because it's not the height of the tsunami that matters, but also the flow and movement of the water. Not to mention the flooding, which can damage beaches, harbors, and streets. If the coastline has a small harbor and the waterfront is exceptionally low, like Cannes, this natural disaster might be much more dangerous. Tsunamis around 6 feet high can lift cars off the ground, while smaller waves can create walls of water traveling at 40 miles per hour. Plus, there are these smaller events that might not wreck everything, but still can cost a ton of money. For example, large sandbars that move around on the ocean floor, like sand dunes shifting in deserts. They can mess up pipelines or deep-sea cables for internet and communications, and that ends up costing businesses and governments millions of dollars. That's why organizations like UNESCO are worried about the possibility of a dangerous tsunami hitting Europe soon. So they're doing everything they can to prevent apocalyptic scenarios, like what happened in 2004 when an earthquake off the coast of Sumatra, Indonesia, caused waves over 100 feet high in coastal communities, resulting in over 200,000 lives lost. And let's not forget about 2011, when an earthquake off the coast of Tohoku, Japan, triggered a tsunami that reached about 6 miles inland and caused a major nuclear accident at a power station along the coast. Over 16,000 people lost their lives in that tragedy, and the event resulted in billions of dollars in infrastructure damage. These disasters were huge wake-up calls, and we've come a long way since 2004. We're much safer today, largely because the tsunami warning system is highly effective at quickly detecting this dangerous situation. Unlike many other natural phenomena, a tsunami can be anticipated. We may only have a few minutes to act, but if we all know what to do, many lives can be saved. And in most parts of the world, sirens are commonly used to alert people to tsunamis. To sound the siren as early as possible, initial tsunami alerts usually rely only on seismic data. First, specialists receive information about an earthquake. Seismic waves travel about 100 times faster than tsunamis, so they have enough time to analyze the data and see if the earthquake might have generated a tsunami and whether they should issue an initial tsunami alert. At U.S. warning centers, for example, scientists typically issue initial alerts within 5 minutes of an earthquake. If a tsunami is suspected, these alerts may also include information about wave arrival times, recommended actions, and potential impacts. But sounding the alarm is not enough. To save lives, coastal communities also need to be trained to respond fast and in the best way possible. That's why UNESCO produced this program called Tsunami Ready, aiming to train people living in coastal areas at risk on how to act in case of a tsunami event by the year 2030. The idea is to help communities stay safe by teaching them how to protect their livelihoods and safeguard their homes. Being recognized as tsunami ready by UNESCO doesn't mean a community is tsunami proof, of course. It's more like a recognition that they have adopted all possible measures to mitigate tsunami risks. So authorities are helping communities to prepare themselves by installing evacuation signs, establishing security procedures, and creating plans to warn tourists. Like Spain, which distributed tsunami warning signs along the entire coastline, as well as signs showing evacuation routes to higher ground. And Spain better be prepared. I mean, only 7 tsunamis have hit the country since the year 365, so it's difficult to predict the effects of such an event. But they could be devastating, considering that Spanish coastal areas are so economically important. There's also a danger zone in the Averroes Fault, beneath the Barents Sea. If an earthquake happens at this point, people will have only 21 minutes to escape a tsunami. UNESCO has also established 12 tsunami warning centers, which cover Europe as well. This initiative involves 5 centers located in the Mediterranean and Northeast Atlantic regions. These centers can save thousands of lives because they monitor ocean disturbances 24/7. Then, after analyzing the threat, they send out messages based on the event's potential to cause a tsunami. The intensity scale ranges from no effect to completely devastating. And by that, they understand that nearly all brick buildings could be demolished by waves, and even the most reinforced concrete structures could suffer heavy damage. Now, so far, we have mostly talked about tsunamis caused by earthquakes along converging tectonic plate boundaries. In fact, earthquakes have accounted for over 80% of tsunamis since 1900. But tsunamis can also result from landslides, volcanic eruptions, and even meteorite impacts. Experts are also worried that with the current changes in climate, we might see more of meteotsunamis popping up in the Mediterranean. These ones are triggered by freaky weather conditions and can mess with any coastline that's got a shallow seafloor. They might not be as huge or famous as the earthquakes ones, but they can still cause significant property damage and put people in danger. For instance, in 2006, a meteotsunami struck the harbor of Ciutadella on the Spanish island of Menorca. Yachts were tossed into each other and later stranded on the harbor floor as the water receded, resulting in tens of millions of euros in damage. Unfortunately, meteotsunamis in the Mediterranean tend to be stronger during summer, so if you're planning to spend your vacation in Europe, stay alert for any signs of dangerous waves. If you suddenly encounter a tsunami moving in your direction, remember this is the time to react. Move to higher ground as far inland as possible. Pay special attention to any emergency alerts and information, and follow the guidance of local authorities. Most importantly, do not wait around taking photos. Leave the area as soon as you notice any signs of this danger event, or if you hear an official tsunami warning. Hey, stay